Once again, thank you very much for inviting me to this conference. I'm going to talk about the numerical analysis of mining waste slope stability, which is one of the areas of my interest, research interest. Okay, I will use the keyboard. No problem. Thank you. Oh, yes, it's working. Yes. My talk will consists of short introduction, and then I will give a short characteristics of mining wastes. I come from Poland, so I will be talking about the properties of the wastes that we encounter in Poland. Then I will say something about the methods of slope stability analysis, and then I will give you two examples of slope stability analysis and the problems connected with it. And then I will sum up shortly. Mining waste in Poland may come from mining hard coal, lignite, metal ores, and other raw materials. It can be deposited in landfills or built into road infrastructure, like road and railways embankments and hydrotechnical infrastructure like earth dams, embankments of sedimentation tanks. Hard coal and metal ore mining wastes have diverse properties that may change over time. The aim of the presentation is to show a simple approach to predicting the stability of slopes of mining waste with changing values of strength parameters, which means cohesion and friction angle, and the extent of the weakened zone, as well as the influence of seepage through the slope body. Two cases of stability of slopes made of mining waste will be presented. The first one, a hip slope with a buried pressure pipeline, and the second one, an embankment of the sedimentation tank or reservoir. In both cases, weather conditions and the time lapse play an important role, affecting the seepage through the slope body and reducing the strength of the slope building material. The calculations were made using the finite element method with the shear strength reduction method. The result of the calculations is the value of the safety factor based on various strength parameters, range of weakened zone, and they take into account the influence of seepage through the slope body. For loose and medium dense unburnt shale, which is the main waste, at least in Poland, at relative compaction between 90 and 95% from long-term landfills, it's been found that the friction angle ranges from 26 to 46 degrees. So the discrepancy is quite large. And cohesion ranges between 10 and 48 degrees, kilopascals. The cohesion of fresh coal waste is generally low. On average, it varies between 0 and 9 kilopascals. Fine fractions are formed during the weathering and degradation process so that the apparent cohesion may exceed 50 kilopascals. As time passes and the grain size changes, the water permeability of the earth structure made of mining waste decreases. And it's been found that the permeability coefficient is of the order 10 to minus 4 meters per second for the fresh material of sand granulation, and it is of the order 10 to minus 9 meters per second for the material degraded into clay. The risk of slope stability is determined by calculating the value of the safety factor, which is defined as the ratio of actual cohesion over the critical cohesion, and it is also equal to tangent of the actual friction angle over the critical tangent of the friction angle. These critical values are at the stage where the limit equilibrium of the slope occurs. The safety factor may be calculated by using the limit equilibrium methods, assuming as many slip surfaces as possible, or shear strength reduction method used in the finite element method. My research work concentrates on using the finite element methods, so I'm going to characterize briefly the shear strength reduction method. When solving the boundary value problem using the finite element method, stability calculations start from the state in which the force vector of the finite element mesh nodes equilibrates the external load vector caused by self-weight and other static loads and the pore water pressure field, which means that at this stage, safety factor is higher than 1. Stability is usually determined using the Coulomb-Moore criterion, and this criterion will be used in the examples that I am going to present. In the course of further calculations, the cohesion and tangent of friction angle of the materials, all or selected, are increasingly reduced by dividing them by the increasing value of the factor Fs according to the formulas. This is the increasing factor by which the parameters are divided in this manner. After reducing the values of strength parameters, the elastic plastic analysis is repeated without changing the external loads up to the step where it is impossible to achieve static equilibrium of the model. The value of the estimated safety factor is the last value of the reducing factor Fs at which it is still possible to achieve the equilibrium of the model. The main advantage of the shear strength reduction method over the limit equilibrium methods is that the failure mechanism results from calculations. It is not assumed a priori. And now I want to present briefly the first example. This is the heap of mining wastes, and here you can see on the left-hand side that there is a pressure pipeline discharging the municipal sewage from a city populated by 150,000 people. So everything was okay up to the moment when the material was excavated for construction purposes for nearby building site. And this process was done in uncontrolled manner, and there was a threat that the excavation, which became 20 to 28 meters deep, and the slope inclination was 33 to 52 degrees, there was the risk of failure of the slope and the breakage of the pipeline. On the right-hand side, you can see the this discharging pressure pipeline, which consists of two pipes of polyethylene of the diameter 630 millimeters. And the failure of the slope and breakage of this pipeline would cause very unpleasant situation for the citizens of the local community. Geotechnical investigation was done. Dynamic cone penetrometer recognized the density of the of the material in the slope body, and some laboratory tests detected that the parameters of the strength parameters may separate three zones of the material, like you see here, from the loosest one to the densest one. The values of the parameters are here in the table. Several cross sections were done, and two of them were chosen for further calculations, for further analysis. This is an example of one of the models considered in three cases. First one was the model reflecting the structure of the slope confirmed by tests. You see here three zones: this top one, the loosest one, the middle one, and the bottom one, under which there was natural soil in the foundation ground. Then it was assumed that the model consists also of the loose or weathered superficial zone, the green one. And then the third model assumed that the large volume of loose material occupies the soil body. These are models of finite elements, finite element method in the initial state, and some of these elements were removed in the course of the analysis to simulate the excavation. Results. As the results, safety factor was calculated for each case, and here you can see the safety factor values which strongly depend on the extent of the loose zone. As you can see, the significant drop in the safety factor value occurs when the model contains assumed superficial weathered zone. Then potentially very stable slope becomes unstable. And when the slope was assumed to be built of the loose material, safety factors dropped to 1, which means that the slope was on the verge of instability. In the ultimate case, the equilibrium was not found at the initial stage of calculations, which means that such slope is unstable, simply. The second example is the analysis of the embankment of the sedimentation tank, in which waste material in the fluid form is stored. It is colliery discard. And here you see two chambers surrounded by an embankment which is 6 meters high, which means it is not really high. And its slope is quite mild because it is 1 to 1.75. In the chamber number 1, the liquid material is stored, and the sediment is separated from the overlying water, which is next pumped to the chamber number 2. And the embankment was designed, the stability calculations exhibited that the safety factor was 1.96, which guaranteed the safe operation of the whole tank. The material of the embankment was the same as the materials stored in the tank, and this material, this waste, was a perfect material for constructing such embankment, because the coefficient of uniformity was over 3,500, and relative compaction was assumed 0.92 or 92%. The seepage coefficient was tested for this material in quite wide range, and it was found that the permeability coefficient was 7.86 to 10 times 10 to minus 4 meters per second for quite loose material, which means that when the material is in such a state, it is susceptible to piping. And when it is properly compacted, the permeability coefficient is 9.0 times 10 to minus 8 meters per second. And the properties of this material building the embankment are given in this table. And after several years of failure-free operation of the sedimentation tank, with no previous signs of a possible failure, the continuity of the embankment was broken. It was more or less, okay, more or less here. Here you can see the railway siding, which was flooded by the material which flew out of the tank. Here you can see the failure. And the question was, what was the reason? How come that this could happen? Okay, two more views of the empty chamber 1. Several factors that contributed to the failure were possible, which are insufficient embankment compaction, mining vibrations, and the seepage of water covering sediments and water from precipitation through the embankment. I must say that the area of the embankment and the whole tank is located in the area of Poland, which is covered by, with many coal mines, and some rock bursts in underground coal mines could produce vibrations which could influence the loosening of the material of the embankment. To analyze the problem, several cases that took into account different factors were analyzed. This is the one of the models, I mean, the most complete model, which contains waste suspension pressure and the flow rate corresponding to heavy rainfall over the top and the downstream slope of the embankment. Six cases were considered, 4 of them based on the parameter values which were adopted in the design. And first one also assumed that the embankment was impermeable, so there was no seepage, and the embankment was not loaded with the suspension pressure. In the second one, embankment was still impermeable, but it was loaded with the suspension pressure. In the third one, embankment was assumed to be leaking, and the steady state seepage was assumed. Embankment was loaded with suspension pressure. In the fourth case, in addition to the previous factors, there was assumed an impact of precipitation. And cases number 5 and 6 were based on the lowered strength parameters, which means that it was assumed that the embankment was loosened, weakened by, for instance, by the rock burst from the underground mines. And in the first of these two, embankment was leaking, so steady state seepage occurred, and embankment was loaded with suspension pressure. And in the second of these two, additionally, impact of the precipitation was assumed. And here are the results of these analyses. As you can see, by considering different ingredients, different factors influencing the stability of the embankment, we can see how the value of the safety factor drops. But I'd like to pay attention that the most significant drop in the value of safety factor is when the seepage through the embankment is taken into account. For the lowered parameters, seepage through the embankment, suspension pressure, and impact of the precipitation, the value of the safety factor is the lowest. And this is the characteristic value of, not value, but picture of the failure mechanism typical for such tasks, for such analysis. Well, to sum up, the risk of loss of stability increases when weathering changes the grain size and reduces the strength parameters, C and phi, as well as when water moves through the slope body. Even uniformly compacted waste material is characterized by large variations in the values of strength parameters. The material's moisture content, which affects its apparent cohesion, significantly impacts its strength. That's why it is very difficult to thoroughly precisely determine the values of the strength parameters of such materials which are of the fundamental importance during or at the slope stability analysis. That's why such analysis which considers different cases and different extent of weakened zones characterized with different strength parameters are of fundamental importance. Physical and chemical weathering causes gradual loosening of the near surface waste layer and reduces its strength parameters. Stability calculations should take into account original or design state, the initial phase of weathering of the near surface layer of the slope with a reduction in the strength of the waste material and changing extent of the weakened zone, and which is very important, influence of the seepage. That's all I want to share with you. I hope such procedure, such way of thinking of solving of such problem where it is impossible to determine precisely the parameters may be useful, at least for some of you. Thank you very much.
Thank you very much, Professor. Now I request Professor Ramesh M. Bhattavdekar to present a memento to Professor Sternick. Thank you very much, sir. Moving on, we'll now move to the industrial presentations, where we have our partners for the event, McAfee Environment Solutions Private Limited, then Pioneer Foundation Private Limited, Garwade Technical Fibers and Innovative Solutions. We'll start with the representative from McAfee Environmental Solutions Private Limited. Please note that you'll be given 10 minutes for the presentation. Thank you.
connectivity. Yes, good afternoon, everyone. First of all, I would like to thank IIT Patna for this, opportunity to McAfee to represent ourselves and showcase some of the solutions which are very critical in infrastructure. So I would like to, give a brief about the major, things which are happening around and what are the solutions, the innovative solutions which we have, some of the causes of some of the, disasters. And starting from our introduction, we are now present in more than 130 countries across the world. And plus, there are more than 3,300 employees working for McAfee and across the globe. In India, we have 3 manufacturing units and 1 additional manufacturing unit in Nepal. So we basically works in almost all the critical infrastructure, segments and projects, starting from roads and highways, mining, then railways for coastal protection, river hydraulics, so in all the major, infrastructure segments. So environmental sustainability is one of the, major thing towards which our solution, revolves. So these are basically the 4, UN goals, United Nations goals, number 9, 12, 13, 15. So we actually have our solutions which are environmental friendly and very much, reduce the carbon footprint. Now we all know the major disasters. So I will not repeat it now. Some of our, the speakers, they have just told us about these factors. So the key differentiators and, requirements which should be studied before, coming up to any solution of such problems, such, disasters. Those are, of course, geological, geotechnical, hydrological, topographical, and the risk assessment and the prioritization also. So one of the speaker was telling about, the key zones where we should work upon first and then, come on to the next one. So the design aspects, basically identification of the problem, like, the major, I would say, the utmost duty of a geotechnical engineer or, a geologist should be, identification of the right problem and then assessing the right solution for that. Now, the design aspects are very much important and McAfee, so we have our in-house softwares which are being developed on some of the international codes and national codes. And some of the, softwares from Rock Science also, like for slope stability and some other softwares which we use. Now, this is our own in-house software, so anyone can visit on edesign.mcafee.com. Some of the softwares are accessible there, and we are working on more softwares development. So for other sectors as well, or other applications which are not there in our portfolio yet. So the key differentiators also involve the, testing of the solutions. So our solutions, or, I would recommend that all the solutions which should be adopted shall be certified from a recognized laboratory. It could be from, India, or it could be European, or US, or any other laboratory. Now coming to the solutions, especially in the hill slopes or anywhere where there is a slope. So the solutions could be starting from the hillside, then the slope retention, and towards the valley side. So McAfee gives solutions which are basically environment friendly, like I told you. So combination of different systems and different feature units can be adopted from our solutions and can be designed for maybe maximum up to 120 years of life, which are there as per the codes. Now these solutions, basically, I will just run through because the time is short. The solution goes for the slope stabilization. It could be for the complete for the complete global stability, or for the surficial erosion control. Now solution includes anchoring part, or other solutions for the global stability. Now, if I talk about the development in the hills, like, there are a lot of steep gradients there. So starting from from the solutions like embankment or the rockfall protection, and then solutions for developing the slope in case of landslide. Now, what we were just talking about the rockfall solution. So different solution as per the need of what exactly is required as per the site to site basis. Now, these are some of the solutions for the debris flow. Apart from the rockfall, debris flow is also a critical, disaster situation. A lot of cloudbursts are happening in the hills. So debris flow barrier is one of the, major solutions which can be adopted over there. Now, drainage application, of course, drainage can be designed, different drainage chute drains, Gabion cascade, or, subsurface drainage. So all are these mentioned in the codes, which can be adopted, because one of the major reasons for this landslide is in many cases it is the inadequate drainage which is being there. Now, erosion control solutions, I will just run through it. The solution includes some of the mat solution, biodegradable mat or geosynthetics, and plus hydroseeding solution. Basically, mulches and seeds which are mixed with water and sprayed over the surface to provide the proper vegetation. This is a very interesting, innovative solution which we have brought. These are cruciform shaped slope stabilization Erdox panels. These can be anchored to any kind of cable anchors, and anchors we can go up to 15, 20, 30 meters in depth. And these are basically very fast. These can be erected very fast and can be used in emergency measures also. So some of the projects which have been done using these. Now coming to the durability aspect, this is a new advanced coating which we have developed, which certainly gives better resistance to any kind of corrosion, any kind of aggressive environment, be it coastal or any kind of low temperatures or high temperatures. Now, if I talk about ISO codes, which talks about aggressive environment, so actually they do not talk at all about zinc class B. So there are many solutions which adopt zinc class B, but internationally those are generally not adopted. So we'll talk about the highest aggressive environment, which is C4 environment, which should be the critical structures should be designed kept in keeping in mind those aggressive environments. Another innovative solution, basically the sensors which we have brought in to basically gauge any kind of deflection or any kind of changes in the slope angles. So this is a Hellomax system which can be connected to a satellite or it can be connected to a GSM technology. So these sensors, they are being connected. This is a gateway. So these sensors can be connected to a main gateway, which is further connected to a satellite or with a GSM channel. And then further, these can also be connected to already established piezometer or inclinometer. So observations can be made using such systems. So this will give all alerts on your phone, on your email, and there, of course, this application is already there on the Play Store. It can be downloaded. Now coming to the next, the major critical area, ground improvement, which is also needed, especially in the weak zones where we want to put up our structures and the soil do not have that capacity, or a lot of moisture content is there. So these are the methods, basically the shallow ground improvement method, that is basal reinforcement or prefabricated vertical drains for soil consolidation. Or if there are piled embankments, then yes, economical solution can be given using in combination with basal reinforcement, and then geosynthetic encased stone column or sand columns. And some of the case studies, I will first start with very recent international projects, few international projects, and then coming to the Indian projects. This is Mountain Road project in UAE. So the idea was that the government wanted to develop the tourist spot at the highest peak of this mountain, and there was a need for developing the road. So the cut slope was done, and this was the cross section. This was a 32-meter high structure which was being constructed there. Now this is another prestigious project, Museum of the Future Dubai. So one of the fascia systems have been done using the solutions for providing, the green fascia. So we can see the angle of the slope here. It is extremely steep, and the reinforcement and the fascia units are used there. Another project from UAE, Etihad Rail project. So we can see tunnel entry, exit portal, protection works, then bridge abutment works. And this project is one of its own kind in the world. This is an offshore farming for salmon fish. So this structure you will see, this is more than 100 meters in diameter, more than 60 meters in height. A special coating and netting system was used for this structure. This is Ocean Farm 1 project. These are the mining solutions because our colleagues just because a lot of people are from the mining fraternity. Our colleagues they asked us keep some mining solutions also there. So these are some of the mining solutions which we have worked in India and abroad also. So starting from one of the case study of a chromite mine where the overburden dump was destable, and also they wanted to increase the capacity of the existing overburden dump. So these are during the construction photograph, and after construction, this is the natural vegetation which has grown. So we can see how lush green this solution can be. All environmental friendly, structures. These are from the completed, project. If we are starting, if we plan from the starting, so we can increase the capacity of our ponds also, tailing ponds or overburden dumps. So this is a project from Peru, from where, if we have the space scarcity, how we can increase and augment the capacity. So this is the completed structure of a tailing pond there. This is from India in Madhya Pradesh. So this is for erosion control, the surficial erosion control. So in the pictures we can see before, there were a lot of rain curds, gully formation. So how it can be prevented using these erosion control solution. Now for crusher walls, if we want to build a completely vertical, wall, it is also possible. A 22-meter high crusher wall, it was built in Jodha, Odisha. These are using a different fascia, which we all see in the flyovers construction. So if there is scarcity of the stone, this can also be adopted. I will just rush through another, ground improvement project, the shallow ground improvement method. Some of the lining solutions which are used in landfills and tailing ponds. So we are part of the, we can design these solutions and provide that. Then some of the structures from the hills, the landside structures, how we have done the mitigation. So this is during the construction, and this is after construction, how it looks like. This is a recent project in Uttarakhand. This is how it looks like. Another case studies where landslide happened and how it was designed for the hillside protection, then retention of the slope and the valley side protection. Some of the case studies of how it looked like before, then how it looked like after or during the construction. So this is Govindgarh location in Uttarakhand. Yeah, I'm just rushing through. Slope step. It is a very interesting project. A lot of fractured rock was hanging, and this needs to be stabilized. And of course, the hanging part just above the road, it was cut, and a slope retention system was also used over there for retention of the road. And rockfall mitigation solutions, which we all know about, which we talked. So this is from TISA project in Sikkim. I've just finished. I guess. This is a case study from the ground improvement. This is the innovative solution which we were talking about for the slope stabilization. This can also be used for avalanche mitigation, which have been used in India as well. So that was all from our side. So we are just one call away. So we will always be happy to give any solution for any of these sectors. Giving the right solution and assessing that and coming to the solution which is internationally tested. So that was all from our side. Any questions? So you can always get back to us right now or maybe afterwards. We are short of time.
Thank you, sir, for the very informative talk. And now I invite Professor Arvind Kumar Mishra to please come up stage and present a memento to the speaker.
Yeah, please.
Next, we have the representatives from Geobrook. इनका presentation.
Go to Icgeid. दूसरा नंबर. हाँ दूसरा. इसमें तीसरा वाला. कैंसिल कर रहा है. Okay. स्लाइड मोड में ले आइए. इससे आगे पहुंचाओ. ये माउस से भी करेगा.
माउस से भी कर सकते हैं. इससे भी सर की बोर्ड भी है.
ये क्या है? So, good afternoon, everyone. I am representing a company called Geobrook. So, in a few minutes from now, I will tell you about my company, our products, and what we have done till now in India. So, Geobrook is a part of Brook Group. Brook Group is based out of Switzerland, and we are in existence since last 200 years. We are pioneers in infrastructure, you can say. We have an employee base of around 18, now almost 2000. And we have businesses in e-mobility, real estate, transportation cables, like in ropeways. We are also present in energy sector. Our group sister company Ritmire is into hydropower, ultrasonic flow measurement systems. I am representing Geobrook. We are a leading provider of solutions against natural hazard. If you talk about our background, what we have learned through over the years of various natural hazards happening in Switzerland, our engineers have developed first global roll cable netting system, which are used for avalanche protection. And from there, we have started in year 1951, and now we have developed system for slope stabilization, rockfall barriers, debris flow, and also into underground mining surface protection. The core of all of our products is high tensile steel wire. You can see here, it's almost 3 times more than the conventional steel used in the industry for such systems. This is our journey till now. We have started around 1836. And you can see over this timeline, different products we have developed over different period of time. So Geobrook today is right now operating in more than 50 countries with a lot of subsidiaries and partner as well as manufacturing facilities. At present, we have 8 factories, and the recent addition is in India under Make in India initiative. We have started our manufacturing operation in Ranchi. So these are the various solutions, as you can see, right from rockfall, slope stabilization, debris flow, coastal erosion protection, and also in the underground mining. By the way, we are also there in Formula One racing. We supply FIA certified motorsport fencing, and you can find our fencing in almost all the major Grand Prix. So the same thing again here. The key products, if you talk about geohazard, is rockfall protection barriers. As you can see on your left, these range from 100 kilojoule till to 10,000 kilojoule energy level. We also provide active slope stabilization system through high tensile wire over any slope, along with spike plates and soil nails. So these are the key products pictorially. We have high tensile wire meshes. These wire meshes are as thin as 3 mm. And then rolled cable net, as you can see on the screen, spider and Rocco rings for rockfall barrier. For underground support, we provide Minex. These are again high tensile wire meshes, which are used for, in case of fall of ground or rock burst, you can use it as surface protection along with the rock bolts, of course. So I would play a small video to let you understand that all our products which we provide are field tested and can be reliably used. It's 2 minute small video. You can see this is raw fall barrier being tested at different angles, vertically as well as horizontally. This is a debris flow barrier which is being tested. This for underground support. This is motorsport fencing test. Speed is up to 250 km per hour. The car. We, I'm just concluding. 4 slides more. So we also collaborate with leading universities and institutes worldwide. You can see these are three practical labs in Switzerland for testing rockfall. And this, the middle one, you can see there's an artificial slope created with a 12 by 12 meter box. And we take it to an angle of 80 degree. I mean, more than the actual practical slope possible, and test our meshes to that. Apart from R&D and all, we also have, we understand our commitment towards environment, and all our products have a very low CO2 footprint in comparison to the conventional products and solutions. And our group has a net zero target until 2050. Buying products from us, it doesn't mean only the products. We also give all-round care, right from consulting, planning support, help during production, implementation, and approval stage. We be with our customer in the entire cycle. For more, since you are a lot of academicians are here in this in this forum, I would request you to please visit our website. There are a lot of exciting dimensioning tools are available for slope and rockfall and depth flow. And in case if you find something to be discussed with us, we are here till for 2 days. We can discuss more about it. Key references, I'm just passing it through. Thanks a lot.
Thank you very much, sir. We now invite our respective head of the department, Dr. Amit Kumar Verma, to please present a memento to the speaker. And next, I invite the representative from Garware Fibers to please be ready for the presentation.
That is better.
Yeah.
पेन ड्राइव है इनके पास सर ज्यादा बेटर
Good afternoon, everyone. Good afternoon, everyone. Am I audible? Okay, I'll try to stick to my timing. So I'll go quickly through a bit of company introduction, what we do, and a few of our case studies. So let me tell you, I am representing an organization called Garware Technical Fibers. It's an indigenous company which was established in the year of 1976 by late B.D. Garware, who was also a recipient of Padma Bhushan. And it is one of the pioneers of polymer and synthetic textile, both in India and in all of the world. And we have a $500 more than $500 million sales turnover over the year, and we have several verticals, so which I'll go through later. So we are present across 75 countries globally. We are a AA rating organization, and we are traded in both BSE and NSE, and those who are interested in stock markets will be knowing Garware stocks are doing very well. So we have a well set up R&D division in Y, which is close to Mahabaleshwar, and we have already 25 patents filed, and some more patents are coming this year, are filed this year. So we are one of the highest exporters of sports goods from India. We are consecutively third year among the India's top 50 best places to work. And we are also featured in ET Now's among India's finest workplaces. So these are the some of the verticals under Garware Group. We are in fisheries, aquaculture, shipping, sports good, agriculture, and I'll be talking about geosynthetics. And we are also in coated fabrics and platina. So we have all these ISO certifications, and where we assure quality standards international quality standards. These are also our quality assurance and credentials, and we meet all the qualification to supply to USA and Canada, and we are doing exports to all over the world. As I said, more than 75 countries. These are all the certifications. Both our labs, both in Y and Pune, both our labs are also certified. These are audited also. And so international presence, as I said, 75 countries, more than 6 overseas offices we have. So quickly, I'll go through geo and environmental applications. So we are present in almost all the geohazard mitigation solutions that are to be provided. We are in landfill, we are in slope protection, we are in river training, coastal protection. Quickly go through some rockfall and landslide mitigation measures that we have done. This is in Udaipur under North-Western Railway. It was slope stabilization was done for Western Railway. This is in Philippines. The client was the local PWD over there. This project was one of the prestigious project under NHI. It is in Uttarkashi and the area is called Nalupani. It was a composite solution. So there were gabion structures, there were rockfall barriers, there were erosion control measures along with high tensile mesh. So this is what the location looked like when there were landslides. So it's a long stretch of around almost 2 kilometers. So this was done. This is a few photos from the construction phase. And this is how it looks. And it has already surpassed quite a few monsoons and it's standing quite nicely over there. As you can see, I don't know if it is visible or not, but there could be seen the barrier, the mesh, erosion control mesh, and also the mesh that was given for landslide protection. This is another prestigious project that we have done in NH 301 avalanche barrier in Kargil. This is also under NHAI, National Highway Authorities of India. This is a total scope of more than 11 kilometers of snow fencing and avalanche barrier. So this is how it looks. This is one stretch. This is how it looks after the first snow. So you can see it's quite neat, looks quite nice. Coastal and river protection. This is from phase 1 of port terminal in Hazira. Phase 2 we have completed very recently. There we have done this riverbank protection with PP rope gabions along with other solution. PP rope gabions, this is very suitable for, where there are chemicals, where there are, it is not susceptible to chemicals and it is not susceptible to UV rays. So it is phase 1. Phase 2, in phase 2, we have recently completed phase 2. It's in Gujarat. This is Upada. This is India's first coastal protection with PP rope gabions. This one is in Pentha. This is also the next one, the second one, coastal protection. As you can see, it is taken after the completion of the project and just a few more minutes. Around, I visited there 2-3 months back. So some land also has been reclaimed. So this is quickly I'll go through. So protection with erosion control mat, landfill and lining. So recently we have developed this totally make in India product, which is landslide early warning system, one of the very first make in India landslide early warning system. So the project outlook is basically was to create necessary alerts and triggers, which can give us enough time so that we can, prevent the damages that gets done by a landslide. At least we have that much time so that we can save human lives. So that was the basic aim. And so 1 minute, just close concluding. So this is as per the report of GSI, total mass, India's total mass, around 12% is susceptible to landslide. So, it's our way of contributing. So we have devised this. It is being devised along with Indian Institute of Science, Bangalore. And it's a IoT enabled, and it will send you, it's a cloud-based system. It will send you triggers and alarms when there is a movement. So yeah, this is how it looks, the demo side. This is how it looks. And that is all. We are here for 2 more days. Anyone interested to know more, you can please come to our stall. Thank you.
Thank you, ma'am. And now I would invite Dr. C. Savliama from SIMFER CSIR to please present a memento to the speaker. Next, we'll have the representative from CADFEM. I invite the representatives from CADFEM to please be ready with the presentation. You'll be given 5 minutes exactly for concluding your presentation. Thank you.
leveraging बोला.
So thank you all. Thank you so much for giving me the time. So let me just quickly go through. So we are from CADFM. So CADFM is a basically 40-year-old company. We are a German company. We got a global headquarters in Munich, and we basically developed the ANSYS simulation software. We have got our own extension. And we got our office in India. We have started our India operation in 2007, and we have got a regional offices in Hyderabad, Bangalore, Pune, and others. So this is something about the comprehensive simulation platform. So here basically we are more working on this digital twin and embedded system. Structures, fluid and electronics and semiconductor and optical, these are all used by our research institution. Currently we are promoting more our digital twin, so that whatever the data you are generating from your mines, your geotechnical activities, you can basically use your data through the AI/ML techniques and try to have a reduced order modeling techniques and try to understand the predictive maintenance of your mines. So how you can do that? This is about our ANSYS product portfolio. What are the products we have got, starting from materials, embedded systems, safety analysis. Typically in research institution, our structure, fluids, and electronics are very much popular. For the time constraint, I'm not going much more deeper. So here we are basically, in my presentation, I will be focusing more on the two areas. One is mining operations, and second is mining equipment development. So in mining operation, we focus more on the blasting side. It's a very popular software we used in mining operation for blasting called LS3C/LS-DYNA. So the workflow is basically, we basically create a detonation of explosive and create a crater. And we see that how the shock wave is affecting the soils and what is the impulsive effect in the structures and soil. So in my upcoming slides, basically how the sequence of events happen during the blasting explosions. So what we are trying to do in LS3C/LS-DYNA, we are trying to create the mimic of this operation in the LS3C/LS-DYNA and trying to understand what is the effect. So the benefit of using the software, basically you can take the extreme condition and the normal condition also. But when you are setting in the experiment, you can only perform the ideal conditions, what can be gone wrong and what can be do things. But software can do all sorts of things. So this is basically the sequence. The explosion donates, shock wave hits the structure, max local deformations, impulse transfer reached, and maximum global. So it's more like a theory, but let me just give you how this works. So if you see the brown one, it is basically a soil where it is basically a soil. We basically define the soil, what kind of soil it is, whether it is a clay, what is the structure of that soil, what is the metal of that soil. And the light blue one is basically the air. So we are doing the blast in the middle, and how the blast is happening, that we are trying to do the experiment. So in order to test our software, to validate our software, we basically done the experiments. So this is one example of the experiment. So in the extreme right side, so in the extreme right side, you can see there is one charge, one target structure, and the air we have taken as a domain. You can also perform the underground blasting. Just for the experiment purpose, we have taken air as a domain, and we perform the studies. So in this case study, what we have done, in the extreme left, if you see, the charge has been placed, and the blue one that you are showing, how is the overpressure? When we say overpressure, what is the shock wave basically happening on the structures? And in the extreme right, we have done the three graph that how the overpressure is happening with the time. First, we have calculated with the experiments how the experiment in the experimental data, what is the overpressure we have gone. Second, in the AR 3D, when we have done the AR 3D software, how the experiment has done. And third is the LS-DYNA. So we try to mimic the experiment in the LS-DYNA, and we found that approximately our software basically matches with the experiment around 90 to 95% time. So anybody can ask me how your software is very much good at work. It all creates that how is the input you are getting. Software is always a garbage in, garbage out. This all software works on the equation-based modeling only. So you can use your own equations and do the modeling. The more size you want to do, the more you have to basically define your inputs. The more refined inputs you are giving, the software give you much better results. So I have given this link. Maybe after the presentation, I can share with the coordinator these slides, and they can share back to you. So here it is a detailed presentation that how we have done the experiments. Second thing, first we have done the mining operation, we have done the blasting, we got the coal. Now how we are going to do the staining of the coal, how do we are going to screening of the coal. So for that we use these types of equipments in the mining industry: mills, crusher, transfer chutes, vibrating screens, mixers, bucket conveyors. In the extreme right side, you are just seeing the software that Rocky DM basically used for the particle flow, typically used by the vibrating screens. So mainly our mining in the mining industries, when they are working for the vibrating screens, they basically use for the particle and they use for these vibrating screens. Only 1 2 minutes. Just 2 minutes. So this is basically for the excavator bucket simulations we have done. We have coupled with Rocky with our ANSYS mechanical and done how the effect is going to happen. This is basically the vibrating skills typically used by the mining industries. So you name it, any mining companies. So all companies use the vibrating skills to basically strain the coal from them. So they try to use that, how the straining will happen, what kind of screen they will be using it. Some another example is for high pressure grinding rolls. And for the viers also, it is basically used by the pharma companies when they are going the viers. This is some of the, for the timing, I'm not going more on this one. This is basically, we are doing the fatigue life prediction. This is the case study basically predicted by the Joslis tank. One thing, just give 1 minute. This is very important one. Those who are from the research institution, those who are still doing PhDs. So we have launched on ANSYS innovation courses. It typically works on the same concept on NPTEL. You can just go and launch your login ID and just use the login ID, do all sort of learning, irrespective of the physics you are working on it. So currently we have got this much physics with that: structure, fluids, electronics, discover, Python, optical metal, all sort of physics are there. And let me remind you, this is totally free. You can learn everything from there. For the certification, like NPTEL, we pay some monetary amount of 1,000, 1,500, we get certified, you can pay over there. But here it is completely free. All the learnings, videos are totally free. Only for certification, we charge something very minor amount. And still you have any questions, my email ID is there, my phone number is there. Please give me a call. We are more than happy to help you out. Thank you so much. I'm really sorry I took more time.
Thank you very much, sir. And now I invite Professor Kripamoy Sarkar from IIT ISM Dhanbad to please present a moment to the speaker. Just a piece of information. The technical sessions on landslide, technical session 1 and technical session 2, tunneling and case studies in underground mining and ground control, would be held in LT001 and LT002 on the ground floor. All those interested may please assemble in the respective halls. The technical session 3, mining and energy geotechnics, would be carried on here in LT003 after the theme lecture session. Beginning with the theme lectures, I invite Shri Abdul Basit, the regional officer at the National Highways Authority of India. Mr. Basit has been conferred with the National Highways Excellence Award 2021 for outstanding works.
है ना?
No. 3 यहाँ पे होगा.
ये रूम नंबर कौन सा है?
ये 003 है.
हाँ, 3 में ये रहेगा सर. ये नहीं है ना.
अच्छा, ये लोग नहीं
हैं और ये कैसे हैं? डॉक्टर के सिंह.
अच्छा, डॉक्टर के सिंह.
हाँ
सर.
एक अच्छा. ये शायद नहीं आएंगे. सबका स्टार्ट
कर. ठीक है.
पहले चेयर को बुला हूँ.
चेयर बट वो उसमें पहले चेयर को बुला लें पहले.
चेयर को बुला के. ठीक है.
मेरे पास दूसरा शेड्यूल आ गया.
अभी यही है टाइम. You can enjoy this time. ठीक है, चेयर को चेयर शोर से मैं बता देता हूँ.
For technical session 03, that's mining and energy geotechnics, I invite Professor Arvind Mishra, Director CSIR SIMFER, and Dr. Rajesh Rai from IIT BHU as the session chair and co-chair to please take their respective seats upstage. Professor Arvind Mishra and Dr. Rajesh Rai as the session chairs and co-chairs for technical session 3. Beginning the technical session 03, we have Dr. A.K. Singh, former scientist, CSIR SIMFER. Dr. A.K. Singh completed his PhD degree from the Indian Institute of Technology, Kanpur in 1991. He headed the Methane Emission and Degasification Division at CSIR SIMFER for a period of almost 2 decades. He has led 100+ projects as a project leader and coordinator in diverse areas, such as the estimation of fugitive methane from coal mines in India, coal bed and potentiality studies, underground coal gasification, and carbon sequestration. He is a lead author in 3 reports of the Intergovernmental Panel on Climatic Change, as well as data provider for the IPCC Emission Factor Database. Please put your hands together for Dr. A.K. Singh.
कौन सा? Good afternoon. Chair of the session, Professor A.K. Mishra, and co-chair, Professor Rai. I have been asked to give a talk on disasters in coal mining. So I have chosen the topic explosion disasters in Indian coal mines, examining the role of coal mine methane. What is the role of coal mine methane? And recovery in long-term mitigation strategies. This is my topic. We know that there are several types of man-influenced disasters, starting from industrial, engineering, nuclear, biological, environmental, and others. Today, I will concentrate on coal mining only. Disasters in mining, though it is not a formal definition of disaster, but it is assumed that a mining disaster refers to an accident that occurs during extraction of natural resources, maybe it is coal, ores, minerals, and more, where the toll of casualties reaches 10 or exceeds 10 in mining. Mining disasters can stem from diverse factors such as leaks of hazardous gases like methane, dust explosion, mine slope collapses, inundation, and mine fires. And of course, there are various other regions, but these are the main regions. If we speak about the history of mine disasters, coal mine disasters in the world, the worst disaster has been on 26th of April, 1942 in anything to say, sir? Okay. In Bangshu colliery disaster in China, wherein a total of 1,549 workers lost their lives as a result of a gas and coal dust explosion in the mine. In our country also, the Dhori mine disaster was caused due to this only. In India, on 27th December 1975, Chasnala mine disaster was there, wherein 372 miners lost their lives in the most tragic coal mine accident in India caused by inundation. The movie Kalapattar of Amitabh Bachchan portrays the tragic event. On 13th May 2014, there was another disaster. There have been several, but I have listed only 3 in this. Soma mine disaster in Turkey, where 301 miners were killed. And this was initiated by explosion, followed by mine fire that persisted for 3 days, and these many lives were lost. Note that safety is not, though mining is considered as a hazardous profession, but safety is there. In our country, the Directorate General of Mine Safety takes care of this. And these are regulated by mainly 3 acts: the Mine Act 1952, the rules and regulations, bylaws framed thereunder, the Indian Electricity Act 1910, the Indian Explosives Act 1984, and so on. Here in this slide, I have listed disasters in 4 coal mines in India. And the first one was in 1936 in the Poidi mine in Raniganj coalfield, which is the easternmost coalfield in Damodar River Basin. And here, number of casualties have been 209, and it was due to explosion of fire dam. In 1952, the Chinakudi mine disaster in the Disargarh seam was there, and 175 miners were killed, and it was also due to explosion of fire dam or explosion of methane. In 1965, Dhori, which I referred to in the last slide, 268 miners lost their life, and this was also due to explosion initiated by methane and then followed by coal dust explosion. And Chasnala, that I discussed, is the biggest mine disaster in the history of coal mining in India. In this slide, I have listed almost all, maybe I have left 1 or 2. So far, there have been 58 disasters in India, and 23 out of them, 23 out of 58 have been due to explosion. So in terms of percentage, 40% of the disasters have been caused due to explosion. And in terms of casualties, out of 2,237 number of casualties, 1,187 have been due to explosion of fire damp or coal dust explosion, which is 53%. Here it is shown in a chart, And here again, the same data in pictorial representation have been shown. And you can see that 40% of the number of disasters have been due to explosion of fire dam. And again, in terms of number of casualties, 53% have been due to explosion. So this is very, very important. Now you may ask why this methane explosion takes place. And what is fire dam? Fire dam is basically methane gas. 95% of the gas is methane only. And it is a byproduct of coalification process, coal formation process, and wherein other gases are also produced. And these gases which are generated during coalification process is different from that of natural gas. The conventional natural gas reservoir is a high pressure reservoir wherein the gas generated from a source rock and it gets accumulated somewhere else. So in a conventional reservoir, the gas is generated somewhere and it is stored somewhere else. But coal reservoir, the coal bed methane reservoir is both the source and host rock for the gas. And so the genesis of coal, gas in coal is the coalification process. And it is a very, very slow process. For example, if you take the history of coalification in Jharia coalfield in India, the coal formation process has taken about 250 millions of years. And the gas so generated is contained in the coal seams, as I said. And if it is released in the mine, the property of methane is such, if its concentration in air by volume is between 5 to 15%, it forms a highly explosive mixture. Here, it has been shown on the right-hand side. If you see the coal through a microscope, there are several micropores. And if you see through a naked eye, you will find that there are certain pleats, fractures, natural fractures in the coal. So there are two types of fractures, the micropores and the macropores in the coal porous network. And you will be surprised that the porous network of coal, has a very large surface area. It is reported, you may not believe, but we have tested in the laboratory also, that per gram of coal, it has about few hundred square meters of surface area. And on this surface area only, so you can just assume that per gram, the total surface area is of the size of half a football field. It is so large. And in this surface area only, the methane gas is adsorbed. It remains in the adsorbed state. And this adsorption is physical adsorption, not a chemical adsorption. And it is mainly due to pressure. A coal seam occurs at a certain depth, say 400, 500 meters, maybe 100 meters. So at a depth, there is some hydrostatic pressure. The thumb rule is, if you go below 100 meters, there will be a coal seam will be subjected to a pressure of 10 kg per centimeter square. So per 10 meters of depth, the hydrostatic pressure increases by 1 kg per centimeter square. And because of this pressure only, gas remains in the adsorbed state. And since it is a physical adsorption, therefore it is a reversible process. So if you reduce the pressure somehow, and what is that somehow? I will speak in the next slide. So if you reduce the pressure, the first thing that happens is the gas which is in the adsorbed state gets dissolved from the surface, and it is still in the microporous system, in the micropore of the coal. But once it is in free state, then diffusion takes place. And this diffusion follows Fick's law of diffusion that we have read in intermediate classes. And finally, it comes to the cleat system. I showed the macropore. And once it reaches the macropore, then there is Darcy's flow. This is again a very famous law, not a new law, proposed by Henry P.G. Darcy in 1884. So it follows Darcy's law and flows in the coal. So this is the transport mechanism of methane gas in coal. Now let us see a schematic diagram of a coal mine. And here in this schematic diagram, only one coal seam has been drawn. And this is a very thick seam. And you know that height of the extraction cannot be more than 3 meters in general. Am I right, Professor Mishra? And there is a restriction in width also. So somehow in the development stage, we create tunnels, which is known as board room. And this is the pillar which is left to give support to the roof. So this is created. Secondly, in an underground mine, what we do is we have ventilation system. So what happens here to ventilate the mine, sufficient amount of, this touch screen, there is sufficient amount of air for ventilation purpose. And in the roof, in the pillar, there is methane gas. It comes to the mine working. So inside an underground mine, what happens is that there is a mixture of methane and air. And if by regulation of DGMS, if percentage of methane anywhere in the return airway exceeds 0.75%, mine will be immediately closed. So there is a regulation. Generally, in underground mine, in degree 1 mine, methane percentage will be negligible. It will be, because of dilution by ventilation air, methane percentage will go below 0.001%. But in degree 3 mines, it is significant. I am skipping few slides. Okay, so I was referring the first thing, and that is presence of methane in coal is a major safety hazard. Second problem is that the open cast mines. Here also methane is emitted, but since there is no enclosure, therefore there is no chance of accumulation of the gas in the chamber. And the gas which is released, it immediately diffuses to the atmosphere. And therefore, there is no safety issue. But whether methane is emitted to the atmosphere, it is vented from underground mine or open cast mine, in both the cases, it is a safety issue. Methane being a greenhouse gas, it is an environmental issue. So the second issue is, first one was safety. Second one is increasing abundance of this potent greenhouse gas to the atmosphere. So CIMFR, wherein I used to work 6 years back, is the nodal agency on behalf of Ministry of Environment, Forest and Climate Change. And we prepared the greenhouse gas inventory, fugitive methane gas inventory to the atmosphere from both underground and open cast mine. And I shall skip the methodology because that is not the subject of today's discussion. And you know, what is the solution? Solution is, can we extract this gas, methane which is present in coal, can it be extracted? The answer is yes, it can be extracted. And if we extract it well in advance, prior to mining, what will happen? It will make our mines safer, number one. And number two, it will also reduce, it will also help us in stabilizing the emission of this greenhouse gas to the atmosphere. So this subject I will skip. So today we will discuss about coal mine methane only. Coal mine methane means methane can be extracted from an underground mine. Coal mining is in progress, and simultaneously can we extract this gas and utilize it as a clean energy resource? The answer is yes. When I was in CIMFR, we studied this potential of this gas, and there we selected three. This project was funded by United States Environmental Protection Agency, and three coal fields we selected: Raniganj, Jharia, and East Bokaro. And there were two categories. One was the existing mine. So in Raniganj, we selected Kalidaspur and the Ghusik collieries. In Jharia, Amlabad and Bhaddi colliery. And in East Bokaro, we selected Jarangdi and Swang mine. All the mines are underground mines. We also selected some virgin blocks. Those have been allocated for future mining. So there were 6 blocks which are listed in this slide for coal production. So here also we estimated what is the potential of coal mine methane extraction. So these are our estimates. Of course, the project took 3 years of time. And Kalidaspur colliery and the Bakulia adjoining virgin block, here we estimated that there is 2.51 billion cubic meter of gas. And similarly in Ghusik, 2.58, in Murlidi, BCCL, 1.52, in Amlabad, 2.23, and in Jarangdi and Swang collieries of East Bokaro coalfield, 2.79 billion cubic meter of gas. And in the projectized coal blocks, we found that there is significant amount of coal mine methane resource, the highest being in Kathara block of East Bokaro coalfield. In Asnapani also significant amount of 6.64 BCM of gas was there. So the major achievements of this type of project would be continuous CMM recovery and utilization in Damodar River Basin can give us 3 to 5 megawatt of power on each mine site, which is not sufficient for running a mine, but of course it can supplement supply of energy to a large extent. So for the extended reading, there is a book by me which has been co-authored by late Sri P.N. Hajra, who was general manager in ONGC. And here we have detailed the methodology, etc. And the book has been published by Springer. So the recommendations are for future are pilot scale demonstration of CMM in a gassy mine should be started. India is yet to start, but I know that in the Kapuria block, there is a private company, PEPL, Prabha Energy Private Limited. They have started this project, and here I think in this year, 2024, production of CMM will start. And if at all it starts, this will be the first CMM project in India. Revamping efforts for R&D projects on VAM, ventilation air methane, should also be initiated. And it is my good luck that session chair is Professor A.K. Mishra, who is not only a renowned mining engineer of the country, but also heads a national laboratory. And I request you, sir, to please take care of this ventilation air methane project. Once, when I was in service, we formulated a project proposal for Buneti mine, and a company, Tata Project, they agreed also to fully fund the project. But due to some reasons, the reason was Coal India board actually agreed for that. But later it was pointed out, why did you select Tata Projects? There should have been a bidding. Maybe some other company might have offered more money. So due to this technical reason, we could not proceed. But this has also a potential. But at least at 3-4 degree 3 miles, where methane percentage in return air is more than 0.4 or 0.5%. Here, one point I would like to make, sir. There is a mine very near to Asansol, Kuwardi mine, very near to Gusik. There, you know, sir, I have made several visits. They produce hardly 60 to 70 tons of coal per day. And main bottleneck is the presence of methane. So in such mines, we can extract methane, CMM, ventilation air methane. There I have noticed methane percentage is always around 0.6% at this low rate of production. If we increase the production, it may go beyond. Assessment of AMM resource is yet to start in the country. Since I referred, we prepared a methane emission inventory from coal mining and handling activities. Several times, United Nations Framework Convention and Climate Change have given their comment. India has several abandoned mines. Why don't you have any estimate? But due to some technical difficulties, this is yet to start. And I will request Professor Mishra again to, this is within your domain, sir. The scientists can do it. Later, industry people will also join. And preparation of national emission factor for these things means abandoned mine, methane, etc., should start. So with this, I thank you, all of you, for giving me a patient hearing, and the chair and co-chair for allowing me to speak without any interruptions. Thank you, sir. So if there are any questions, fine. Otherwise, with your permissions, yes, please.
Yes, sir. Thank you. It was a nice presentation. I'm from NTPC. So I have a question that coal is extracted from the mine, and subsequently the coal ash we are going to fill in the mine itself. So what are the basic changes in the ground the coal ash is making, which the coal itself was not making?
This is a question which is not my area of expertise, but what I believe is that only You mean fly ash? Only fly ash can't be used for backfilling because, because of several properties, it is mixed with, there is a separate department, and I think session chair can throw some more light. But I believe the strength of fly ash is not enough to take the load of the roof strata. So it is mixed with some other materials, and what are the environmental issues, I am not aware of. Maybe Professor Rai or Professor Mishra can throw some light.
Sir, from strength point of view, there is no issue because we have been disposing the ash through.
Which mine you are referring to?
Basically, South Maranda mine, we have already filled with the coal ash in
Okay.
the Odisha.
Okay.
Now we have been given so many other mines, pan-India basis, which are getting progressively abandoned. But there also some imperviousness requirements are there.
You are probably dumping it in open cast mine?
Open cast mine.
Yes, yes.
Open cast.
That's why strength is not an issue. Otherwise, it is an issue.
Yes. Yes.
This is not my area, sir.
Okay.
But if you can give me your email ID, my friend, I will pass it, your question to Dr. C.N. Ghosh. He will be happy to reply.
Sure. Thank you, sir. Thank you.
Okay, sir.
Looking for the answer. I will get the answer subsequently.
Thank you. Thank you. Thank you very much. I think he's the one who will let us know what next.
Thank you very much, sir. May I now request our session chair, Professor Mishra, to please present a token of remembrance to Dr. A.K. Singh. And please put your hands together for Dr. A.K. Singh. Please. Who's the photographer? Okay. He's busy with the 3 rooms, actually. Okay. Thank you, sir. Thanks a lot. Now, moving ahead to the paper presentations, I request the authors of paper number 68. The authors are Bankim C. Mahanta, T.N. Singh, Vikram Vishal, and H.O. Singh. The title of the paper is Nanomechanical Investigation for the Determination of Mechanical Properties of Indian Sandstone. To please be ready with the presentation. Are they here? Paper ID 68. Okay, no problem. Paper ID 72. Are we here? Moving on to paper ID 161, 131, and 39. Do we have the speakers? 131 is here. Okay. So we'll start with paper ID 131 to be presented by Madhurima Mazumdar. $154 and $73. ठीक है, ठीक. 154 and 28.
पता नहीं है, एक बार देख लीजिए डाला हुआ है।
Keynote speaker है इसमें है आपका?
नहीं नहीं मैं मेल की थी ICGEID 2024@gmail.com।
अभी आपके पास है पेन ड्राइव है मेल?
हाँ पेन ड्राइव में है।
तो लाइए
Ten minutes is the time. Yes. Jay.
No, it is.
कॉन्फ्रेंस करके लिखा है ये ये और कैसे हम ये
ठीक है,
वो कैसे रखना है
हाथ में भी रख सकते हैं।
Good afternoon, everyone. My name is Madhurima Mazumdar, a research scholar from IIT ISM Dhanbad. Today, I'm here to present my paper on the topic of quantitative evaluation of subbituminous coal from Jharia Basin, India, investigation using low pressure nitrogen and carbon dioxide adsorption. In the current scenario, the demand of natural gas is increasing day by day in India. Coal is one of the key unconventional
Ms.
reservoirs,
Madhurima,
which
you need to finish within 10 minutes. So time allocated to you is 10 minutes.
Okay.
Please, thank you.
coal is one of the key unconventional reservoir of CVM, which can also be a potential future energy source for India. There are some few intrinsic properties such as volatile matter, moisture content, wet net reflectance, fixed carbon that controls the quality of coal, and these also are affected by the rank of coal. Apart from all this, pore structure is also influenced by the rank of coal. So several studies have showed the enrichment of micropores with increasing coal rank. Due to this presence of nanopore, it is difficult to recover the methane adsorption directly from coal. So therefore, this needs to be studied in details. In our present study, low pressure nitrogen and carbon dioxide gas adsorption were analyzed to characterize the structural attributes of pore, the relationship between the total pore volume, specific surface area, hysteresis coefficient, and fractal dimension all are analyzed, and how all these aspects are related with the rank of coal is also discussed. Samples were collected from 2 coal seams of Jharia coalfield, which is situated in the Jamadoba coal mines in the central part of Jharia Basin. This is the stratigraphy of Jharia coalfield, which comprises from Upper Carboniferous to Jurassic age. This stratigraphic succession overlies on the Precambrian metamorphic basement, which is followed by Talchir boulder bed, coliferous Barakar formation, non-coliferous Barren Major formation, and coliferous Raniganj formation. Our samples represent the Barakar coal bed, which comprises the 2 coal seams of B11 and B14. This methodology we have used in our study, which comprises this analysis. The proximate and ultimate analysis corresponds to the material composition, and low pressure carbon dioxide and nitrogen gas adsorption corresponds to the pore characterization of coal. Using Micrometrics 3-flex 3500 surface area analyzer, the low pressure nitrogen and carbon dioxide gas adsorption were performed on the prepared specimens. The adsorption measurements can give us the adsorption isotherm and the volume of adsorbed gas in different relative pressure range, and this can give us the adsorption isotherm point by measuring the nitrogen gas at different equilibrium pressure. The desorption isotherm we can also be obtained by measuring the amount of gas that is removed from the sample during lowering of lower relative pressure. So this gives us the hysteresis loop, which is mainly associated with the multi-layer gas adsorption and corresponds with the capillary condensation. Here, De Boer has classified 5 types of hysteresis coefficient and associated them with different type of pore shapes. Here, type A is associated with the cylindrical shaped pore, type B is associated with slit shaped pore, type C and type D is associated with wedge shaped pore, and type E is associated with bottleneck pore. Low pressure nitrogen gas absorption were done within the pressure range of 0.01 to 0.995 at constant temperature of 77 Kelvin to analyze the meso and macropore. And the low pressure carbon dioxide absorption was done within the relative pressure range of 0.01 to 0.995 at a constant temperature of 273 Kelvin to analyze the micropores. From the results of proximate analysis, we can see moisture content varies from 0.83 to 1.17%. Volatile matter varies from 16.79 to 18.40%. The ash content varies from 20.70 to 31.30%. If we look into the result of ultimate analysis, the percentage of carbon varies from 53.98% to 62.37%. Hydrogen content varies from 2.91 to 3.18%. Nitrogen content varies from 1.29 to 1.33%, and sulfur content varies from 0.477 to 0.58%. The result of low pressure nitrogen gas absorption exhibits type A hysteresis loop, where the desorption isotherm almost coincides with the adsorption limb, exhibiting hardly any kind of hysteresis loop. The reason behind this may be due to the presence of open type of pores, which is mainly dominated by cylindrical type of pores. Here, the isotherm curve of carbon dioxides are represented using the type A curves, which indicates the presence of mesopore, micropores, sorry. On the basis of non-local density functional theory, using the low pressure nitrogen and carbon dioxide gas absorption, the pore size distribution of both samples varies within the relative pressure range, within the pore width range of 0 to 100 nanometer. The BT specific surface area of meso and macropore has a range of 1.097 to 1.157 meter square per gram, and the specific surface area of micropore varies from the 0.878 to 0.892 meters per gram. The total volume of meso and macropore varies from the 0.003 to 0.443 cc per gram, whereas the pore volume of micropore ranges from 0.008 to 0.009 cc per gram. The pore size distribution of meso and macropore mainly exhibits the multimodal distribution and mainly concentrated within the pore width range of 20 nanometer. And the micropore, the pore size distribution of micropore exhibits the unimodal distribution of pores, which is mainly concentrated at the peak of 1.2 nanometer. To better understand the influence of pore structure on the exploration and the development of coal bed methane, it is important to comprehend the pore geometry. So due to its complexity, the standard geometrical method finds it difficult to give any precise assessment and cannot measure by set scale due to the variety and asymmetry of pore structure of coal. So to solve this problem, FHH model can be used to measure the structural characteristics of pore. By using this equation, the fractal dimension can be determined. Here, V represents the volume of adsorbed gas at relative pressure, Vm represents the volume of monolayer coverage, C represents the constant. This equation depicts the dependence of adsorbed volume on the relative pressure, as this equation is in the form of straight line. So the x-axis corresponds to the double logarithm of relative pressure, and the y-axis corresponds to the logarithm of relative volume. By plotting these two, we can get a straight line, and the slope of the straight line will represent the value of A. These two fractal curves indicate the adsorption stages, which is mainly van der Waals region and the capillary condensation region. And this two corresponds with the relative pressure range of 0 to 0.45 and 0.45 to 0.99. dV1 that derived from the lower relative pressure range varies from 2.378 to 2.396, and the dV2 that derived from the high relative pressure range varies from 2.73 to 2.677. Under the influence of overloading pressure and heat, the physical and chemical characteristics of coal vary significantly with coalification. The dV1 that obtained from the low relative pressure range mainly exhibit how heterogeneous the heterogeneity of pore network in spatial distribution of coal, and it does not directly relate with the adsorption capacity of methane. The high relative pressure range of the high relative fractal dimension.
Ms. Madhurima, another 1 minute, please conclude yours.
Okay, sir. The high relative pressure of the dV2 that is derived from the high relative pressure range indicates the roughness and heterogeneity of different type of pores and show a sudden decrement of value from 2.677 to 2.373 as the cold rank increases. Due to the this is due to the compaction of pore morphology along with the qualification. If we see the moisture content, it decreases with increasing depth. So the capacity of pore to absorb the water molecule in their pore network also varies with the pore, also influenced by the fractal dimension, as according to the favorable relationship between the fractal dimension and moisture content, which has also been seen in the investigation of Zhu et al. So the isotherm curves of the tested specimen belong to the type A, which is characterized by cylindrical pores. The pore size distribution examined the coal samples revealed that the mesopore and micropores are mainly present in our samples. The higher value of fractal dimension indicates how heterogeneous our pores and how rough our pore surface of coal specimens are. The moisture content is positively correlated with the fractal dimension and negatively correlated with the depth, indicates that the moisture content has a significant impact on pore structure of coal. These are the few references that I have used in my study. Thank you.
Thank you very much for completing your talk within time. Now it's open for questions, if there are any questions or doubts. No, I think it doesn't look like. Okay, thank you. Wonderful presentation. Thank you very much for your presentation. We'll go ahead with the next one. Yeah, the next one is paper ID 154. That will be presented by Ms. Saheli Ghosh. Okay. What is it?
Next, I invite the authors of paper ID 154 to please be ready with their presentation. So
Okay.
there's a change actually.
Okay, sorry. Okay, sorry. Oh, okay. Who will be the author? So authors are here? Or the speaker who is going to present?
Paper ID 154. Okay, next we have paper ID 28. If they're ready, please come up with their presentation. 154 is not here. The secretary, so please note 154 is not here. So we are proceeding with paper ID 28.
Yeah, so are they here? Okay, thank you.
नहीं ये ना कीजिए चिन्मय सिटी चिन्मय ये वाला जी 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 कहाँ पे
Go ahead.
Yes,
You have 10 minutes.
yes, thank you, sir. Good evening, everyone. My name is Chinmay Sethi. I am an ACSI research scholar, currently doing my doctoral research under the guidance of Dr. Bodhisattva Hazra at CSIR SIMFA. My topic is evaluation of brittleness index of different shale lithotypes from Rajmahal Basin, India. So in the recent years, unconventional shale formations are being widely researched, and due to its substantial hydrocarbon reserves, and the technology being used most widely is hydraulic fracturing. And to develop a very good hydraulic fracturing program, the most important properties are geomechanical properties. And among the geomechanical properties, brittleness index is very important. It's very critical. So What is the importance of brittleness for the shell plates? If the shell plates are not brittle, then the fractures which is being induced through hydraulic fracturing, it will be closed very soon. So rendering the reservoir useless. So for that purpose, it is very important to evaluate the brittleness of that particular reservoir. But measurement of brittleness is very, it's not very accurate in the sense that there are numerous definitions. Different researchers have given different methodologies, different approaches to how to calculate brittleness index. So in this study, we have tried to use different types of brittleness index measurement approaches and applied to different shell varieties obtained from Rajmahal Basin of India. So different shell varieties are sandy shell, shell with sand laminations, poly shell, intercalated shell, carbonaceous shell. So we have taken shell samples from different depths of a borehole, which was obtained from Rajmahal Basin of India, and we have actually selected it on the basis of TOC, that is total organic carbon. So our objective was to verify the effect of brittleness of different cell varieties and then compare the different brittleness indices calculated for those particular shell samples. This is the study area. It is Rajmahal Basin. It is situated at the northeast of Damodar Valley. And the samples were collected from Lower Gondwana, it is early Permian, and from Baraka Formation. So these are the depths from which samples were collected. It is ranging from 231 to 674. So the samples were first prepared for mechanical properties analysis. These are prepared as a cylindrical specimen in both sizes. One is length to diameter up to 2 and another is length to diameter ratio is 0.25. And the standard followed was ASTM. So the diameter of the samples were 47 mm. The sample, the UCS and Young's modulus Poisson's ratio, the mechanical properties of these shell samples were obtained from MTS system, a rock mechanics test system at CSIR SIMFA. And the TOC, the total organic carbon, was calculated using rockable. We also calculated the mineralogical composition of the samples, that is using XRD, and also the physical properties to evaluate the whether microcracks are there or not. We have calculated it using ultrasonic wave velocities, P and S wave. So we have used actually 6 brittleness indices, and those were broadly separated as mineral-based indices and mechanical-based indices. So this is UCS and BTS-based approach. Basically, we have calculated the uniaxial compressive strength and tensile strength of the samples. Then the ratio of both gives us the brittleness index, because if a sample's UCS is high, then it will be difficult to close the fractures. So more strength will be required to make the fractures close. But if the tensile strength is low, the opposite would happen. So the ratio of both would give us the brittleness index. So this is our first indices which I have calculated. And the second one is based on Young's modulus and Poisson's ratio. Third one is also based on Young's modulus and Poisson's ratio, but these are not directly calculated as a static method. It is dynamically calculated in the sense that we have used ultrasonic wave velocities P and S wave to calculate the Young's modulus, dynamic Young's modulus and Poisson's ratio. So that is how we have gotten the BI3 brittleness index. And the fourth brittleness index is ratio of elastic strain and total strain. We have got it from the stress strain curves, which we have obtained from the UCS analysis. And fifth and sixth are mineral based approach. So that was mechanical based approach. This is mineral based approach. Quartz is considered as a brittle mineral, and clay are considered as ductile mineral. So the ratio of quartz and the total mineral content of the samples gives us brittleness index. So in the BI5, quartz plus clay minerals are there, and in BI6, quartz plus quartz plus clay plus TOC is also there. So we have also considered the total organic carbon of the samples, since organic matter is also considered as a ductile matter. These are the results. We found that Kohli shells showed very less UCS compared to other samples that are and the highest was shown by intercalated shell. These are the XRD and TOC calculation of the samples. So the TOC varied from 3.98 to 38.91, which is very high. And I must tell you that we had also calculated the hydrocarbon potential of Rajmal Basin. So those samples were mainly type 2 to 3 kerogen. So those had potential of gas generation. So that's why we have taken samples from there. So the results of brittleness analysis. So BI1, which was based on UCS and tensile strength, we observed that Kohli shell had the highest brittleness index. Opposed to that, BI2 and BI3, that is based on Young's modulus and Poisson's ratio, and the opposite trend was observed. These are the stress strain curves of the samples, different samples. So we observed that sandy shell had the most ductile failure. So the sustained deformation before failure was higher in case of sandy shell, which was the most ductile among the samples. This was based on the elastic strain and total strain properties. So we observed that the failure pattern of the samples were corroborated with the BI4, which is brittleness index based on elastic strain and total strain calculated. So for sample sandy shell, Kohli shell, and carbonaceous shell, we can observe that is SH1, SH3, and SH5. The failure pattern is tensile, but in SH2 and SH4, that is shell with some sand laminations, and SH4, which is intercalated shell, the brittleness index is low, which is ductile, and also in the image we can see the failure pattern is also in a ductile manner. That is shear failure. So we observed that the mechanical based brittleness index and mineralogical based brittleness index also corroborated in a way that UCS based and tensile based brittleness index and the mineral based brittleness index shows same trend. For example, in BI1, that is UCS and tensile based brittleness index, we can observe that Kohli shell has higher brittleness index. Similarly, in mineral based brittleness index also, Kohli shell has the highest brittleness index. So in conclusion, clay rich shell types are brittle compared to clay poor and quartz rich ones. High TOC shells exhibited greater brittleness, contrasting with low TOC counterparts. Yes, so I told you that TOC means total organic carbon content of a shell are more ductile in nature. But in our result, we got that high TOC shells are actually more brittle compared to the low TOC shells. This happened because in these two samples, the quartz content is very high. It is around 80%, 88%. So quartz has much more influence than the TOC. That's why even with the higher TOC, the brittleness index of these two samples are higher. Low strength cells are more brittle, contrasting with high strength shell samples. So even though I told you that UCS and tensile strength ratio gives us brittleness index, so higher UCS should give us more brittleness. But in our results, low strength shells are giving more brittleness because the ratio would depend upon the type of rock type we are using. For example, in Kohli shell, if you are comparing Kohli shell and silty shell, so in that case, silty shell would be more strength. It would have more strength, but it would also have more percentage of clay minerals. So that would also affect. So the purpose of this study is to
Can you conclude? Yeah.
The purpose of this study is to give a holistic approach to our sample to a reservoir. When we are trying to get the brittleness index of that particular reservoir, we cannot go through a particular method. We have to find out each and every possible approaches so that the best possible fracturing program can be created for that particular reservoir. Thank you.
Thank you. Thank you very much. Now it's open for the questions. I don't think any question is there. I think everybody looks like to be exhausted, or you were so good in explaining what you intended to explain. I have a few questions. Number one, did you consider the anisotropic property because orientation?
No, sir.
So that is one aspect probably where your strength will be varying. And second, what for you have been doing this testing, finding the brittleness index? What will be its application? Where are you going to use it?
Yes, sir. Sir, as I told that brittleness, to calculate a brittleness index of a particular reservoir, our approach was to go through a particular, generally what happens is wire logging are used. So that way dynamically it is calculated. But through this method, we observed that a single approach cannot be done. Multiple approach should be there. And that way we are trying to evaluate that what major factors there could be which can affect brittleness index. So it's basically to try to expand the horizon of brittleness index.
Okay. Thank you very much. Thank you for a wonderful presentation. Thank you. Next. Next is paper ID 5151. Okay, so for paper ID 51, your presentation time is 8 minutes and 2 minutes for question answer. So please try to complete within 8 minutes. Your time starts now. Not yet started. Okay. Once your presentation is up, then your time will start in.
So good evening, respected chairperson and co-chairperson, and everyone who is present in this auditorium. Myself, Anand Sharma, working as a technical officer in CSR Sinfer. So today's topic of my presentation is comprehending estimated and actual cut volume of open cast excavation, a case study. So as we well know that in open cast excavation, we require to excavate large volume of overburden. So volume estimation is critical process for the short term and long term mine planning, and accurate volume calculation are essential for the inventory management, resource assessment, project planning, and environmental monitoring. So objective of our study is to estimate the volume of excavation before the financial year 2020 to 21 through a Minex software, and our second objective is to estimate the actual volume of excavation through a TLS, which is called as a terrestrial laser scanner. Then after third objective is to compare both the volumes which we have calculated through both the methods. So in our case study, we have considered Manoharpur coal block of OCPL, which is situated in Sundargarh district of Odisha. So here in this coal block, there are 5 seams, main 5 seams, named as Rampur 1, Rampur 2, Lachkura 1, 2, and Lachkura combined seam. So mine having the lease of 30 years, and the production target which was set for a financial year 2021 was 5.5 million ton. So by considering this target production and on the basis of infrastructure availability present in the mine, we have computed a volume through Minex software. So in mine, the seam having a gradient of 1 in 10, having the stripping ratio of 3.5 meter cube per ton. And number of core drilling we have considered in a Minex software is 238, where the lease area having of mine is 654.276 hectare. So we got a borehole density of 36.39 square kilometer, which is much more than the UNFC guideline. So when we had calculated a volume through a Minex software, first we have considered input parameters like lithology, assay value, seam data, all these things we have considered. Then from that input data, we have prepared a geological model and borehole model. Then after by considering this bench parameter, like bench height, bench width, bench slope, we have prepared an open pit design in a Minex software. So after preparing pit design, we use the DTM to DTM model for the calculation of volume. So in that case, we got the volume of 9.3 million meter cube for that particular financial year. Then in second method, we have computed the volume through a TLS. So for calculating the volume through a TLS, we have established a local station which having the clear visibility to the mine. And after the taking the data from the TLS, we process that data into Atlas scan. So after processing the data, the actual pit profile which we have got is shown in this figure. And the actual volume which we got from this Atlas scan software is 19.61 million meter cube. So in result and discussion, the volume is estimated by a Minex software is 19.38 million meter cube, whereas through a TLS we have calculated the volume of 19.61 million meter cube, which having the variation between these two methods is 0.1% only, 1.1% only. So as per the mine plan, the variation which is acceptable in a limit is suggested as 10% only. So as per our calculation, we have got only 1.1% of variations. So that 1.1% of variation which we got is maybe might be due to cumulative influence of borehole spacing, software interpolation, design profile, and actual mine cut boundary and precision in the survey. So in the last, the use of combination of tools like Minex and Atlas scan software program to perform a volume estimation facilitate field validation is an effective tool for a mining industry. So from this case study, we conclude that the volume calculated through a Minex software is much more accurate for the estimation of volume. So thank you. Thank you, sir.
Thank you. Thank you very much. Now it's open for the questions. No more questions? Okay. Okay. Thank you. Thank you. Thank you very much for the wonderful presentation.
Thank you, sir.
Thank you.
Next paper ID number 6060. 6060. Next paper ID 5454. So Ashish, you have 8 minutes for presentation and 2 minutes for question and answer.
Thank you so much, sir. Respected chairman and co-chairman, sir, all the delegates of this conference. I am Dr. Vivek Kumar Himansu. Currently, I am senior scientist at CSIR Central Institute of Mining and Fuel Research. My topic of presentation is impact of inaccuracy in design delay timing of delay detonators on reliability of blast-induced ground vibration predictor equation. Before starting my presentation, I would like to acknowledge the contribution of my co-authors, Mr. Ashish Kumar Vishwakarma, Mr. Manish Vishwakarma, Mr. Saket Kumar, Dr. MP Roy, and Professor A.K. Mishra. So basically, this topic is related to ground vibration prediction. So whenever we are doing blasting, before going for a blast, or specifically when we are doing blast in sensitive areas, so before going for that, we used to do predictions near the structure. So these predictions are mostly based on the statistical data of previous blasts that we have conducted. And these predict the safety of the structures depends upon the reliability of these predictors that we have developed. But how much reliable is these predictors, that will depend upon how we have taken the input parameters. So in case of input parameters, the main input parameters that is influencing the blast ground vibration prediction equation is MCPD and distance. Now, MCPD, it is globally accepted that if we are firing 2 holes within a window of 8 milliseconds, then that will be considered as a double MCPD, MCPD of 2 holes. But what will happen if we are considering that both the holes are going at separate delay, but due to inaccuracy in the product, they are going at the same time. So what would be solution for that? So for those, we have used some of the methods. So these are some of the predictor equations that we have listed that is being globally used. And most dominant predictor out of these is Duval and Petkoff 1959 predictor, that is USBM predictor. So we have taken this predictor only for our study. This is about inaccuracy in delay detonator. So first, to start with, we would like to just understand the scattering, or what type of inaccuracy can be in the delay detonators. So first we will see if the delay detonators are very much accurate, then what will happen. Then suppose there are 5 holes, then this will be blasted like this. But if our delay detonators have difference in sequencing, then what will happen that after 1, this 3rd hole will be blasted, and after that the 2nd will be blasted. So it is like this. Sometimes another type of inaccuracy, what can happen is that suppose this is 1st hole is blasted, and we are expecting that after that there will be blasting of 2nd hole, and after that there will be 3rd hole, but both the holes have been blasted together. Similarly, both the holes of 4 and 5 blasted together. So this is not in our hand. This is due to manufacturing defect. But while generating or while developing the predictor equation, we need to take care of these things. So what can be solution for that? So one solution is the use of accurate delay detonators. So there have been developments in initiation system over the years, and these initiation system include some of the accurate delay detonators like electronic detonators. So but those detonators may be costly as well. So what should be the cost effective solution, specifically when we are talking about civil construction projects? So for that, what we can do is that we can do comprehensive analysis, and with the existing delay system itself, we can change the window and derive the more reliable predictor equation. So for this, we have done some of the case studies. We have taken data of some of the mines. Mostly all of the data that we have taken for this study are from iron ore mines, that is of Bacheli, Noamundi, Joda East, Katamati, Khandwan, and Kirandul iron ore mines. And what we do did is that for all of these mines, we have developed predictor equations, USBM predictor equations. And for developing the predictor equation, we divided the data into 70:30 ratio for training and testing purpose. Using first 70% data, we developed the predictor equation, and using the rest of the 30% data, we test the reliability of the equation. And if there is deviation, we calculated root mean square error in the prediction. And after that, at the same time, we have tested the scattering in the delay detonators, and we correlated the scattering with respect to the reliability, that is root mean square error in the prediction. So we collected this data from these sites and established these predictor equations with reliable coefficient of determination using 70% data. So these are the plots of this predictor equation. And after that, we again plotted using 30% data. We plotted what is the actual versus predicted values between the predicted using the developed predictor and 30% data that we measured in the field. And after that, we also considered the scattering analysis. For a scattering analysis, we used high-speed video camera. So basically, we have taken the images of these detonators, and here we have taken different parameters of the scattering, like what is the minimum scattering, maximum scattering, mean, median, mode, first quartile, second quartile, third quartile. So these all data we have taken from the scattering analysis, and we did box plot so that we can identify that what is the minimum, maximum, first and second, third quartile. And based on that, further we correlated the reliability, that is RMSE values of PPV with respect to these values, means these parameters of the scattering, these parameters of inaccuracy. And what we found is that we are getting the relation between third quartile of scattering with respect to RMSE. And the best relation that we are getting is related to maximum scattering with respect to RMSE of PPV. So basically, from here, we concluded that the window that we wanted to shift is related to, it won't be related to the minimum scattering or mean or average value. We need to shift the window based on our maximum scattering or third quartile values. So based on this, further we have changed the reliability of the, changed the predictor equation and changed the window interval for that mine. And based on that, we suggested the mine management to do prediction, more reliable prediction by changing the delay system or delay initiation. So in presentation, I would like to just tell that the most suitable statistical predictor, a statistical descriptor for a scattering that we found was maximum scattering and third quartile. And based on that, we redeveloped the predictors. And by redeveloping the predictors with more reliability, we can be able to predict the ground vibration with more reliability, even with the cost-effective delay detonators. We do not need to go for electronic detonators. We can do using the conventional detonator with more reliability. So this is about my presentation. So before telling thank you, I would like to acknowledge the contribution or support of industry partners, that is NMGC, Tata Steel Limited. And I would like to inform you that recently we have published this book, so that may be helpful for all of us. That is all from my side. Thank you so much.
Thank you, Dr. Vivek. Thank you very much for the wonderful presentation. Now it's open for the question answer session. If you have any query, any doubt, any clarification? No one? I think this is the most decent hall. No one is asking any question to anyone. So that's a pact. I think it looks like that a pact is there between the authors. Okay, it's wonderful. Thank you. Thank you very much, Dr. Vivek.
Thank you, sir.
Thank you very much for a wonderful presentation. Let's move on to the next. Can you go ahead?
Paper ID number 40.
Dr. Narayan, you have got 8 minutes. Kindly conclude within 8 minutes. And your time starts now.
Forward. Good evening to everyone. My name is Dr. Narayan Kumar Bhagat. I am working as a senior technical officer at Rock Excavation Engineering Group of CSIR Simper Dhanbad. Today, I'm going to discuss into the benefits of direction control blasting techniques developed for mainly stabilization of problematic rock cut slopes of Konkan Railway. Before the start of my presentation, I would like to thanks and acknowledge my guide, Professor A.K. Misra, in supporting and helping me throughout my research career. And then I would like to thank my co-author, Rakesh Kumar Singh, and Dr. Arko Jyoti Das for helping me out in preparation of this manuscript. See, I will discuss the case studies of Konkan Railway. There we did this job for nearly 20 years to develop these techniques. And this is all about the Konkan Railway, you know. The Konkan Railway, the worst hit railways in terms of landslide and rockfall, and number of accidents took place there. And it resulted into loss of many lives and injuries of several hundreds of pupils. So this is all about the Konkan Railway. And you can see here the out of 741 kilometers, approximately 11% of total length is through the tunnel, and the 30.5% of that total length is passing through the cuttings, that is having more than 10 meters of heights. So here you will see the challenges this railway faced and which resulted into the accidents of trains and loss of lives. This type of situation also, so our other railways are also facing time to time. This is the scenario you can see here. And this type of geotechnical strengthening measures previously Konkan Railway used to stabilize their slopes, but later it all became failed due to the natural degradation and the slope mass failure. Here you will see the types of failure occurred on this railway. And now I will go to the, apart from this, you will see while the stabilization or the doing the any type of blasting work nearby the railway, then you will see that it sometimes resulted into the fail of that slope and ultimately closure of the routes of that railway. So here we will see that this type of situation occurred at other railways also. And here I want to play one video. This here you can see the contractor has arranged all the things to conduct a very good blast, but ultimately it resulted into the failure of slopes and stopped the closed the railway for hours. This video is not playing. Sorry. After seeing all these things, we try to develop a methodology for the stabilization of slopes. In this, we will see first we study the unstable slopes, that history of the incident, and depth of the slope and slope angle, geotechnical and geological study Or based on that, we decided what type of stabilization methods we should do by doing the kinematic analysis, numerical modelings, and later on I will discuss all these things. Here you will see the 4 cases of 4 cuttings of Konkan Railway, and 2 are in Ratnagiri district of Maharashtra, another 2 in the Uttar Kannada district of Karnataka. This is the details of the cuttings and the associated failure on that particular cuttings. You will see. I will first here, this is the geomechanical properties of the rock mass, and this is the estimated rock mass rating estimation we did there. And this is you can see the analysis for the wedge and for planar failure we did using the software, deep softwares. And that after all this, you will see the probability of failure at all the cuttings were more than 60 or 90% of wedge failure or planar failure. So here, after analysis of data, we found out that when the slope angle will be less than 45 degree, then the probability of failure of planar or wedge failure will be less. After that, we did the numerical modeling with in Flex 3D softwares, and we found that the factor of safety of all the slopes were less than 1. And this is the summary of the stability analysis of selected cuttings. And here you will see after that we decided to make the cuttings in such a way that no failure should occur in future. So this methodology and sequence of excavation we established there. First we removed the soil mixed boulder using the mechanical means. After that we divided the entire width of the cutting into 2 parts, like stage 1 and stage 2, and we directed the throw of blast in such a way that it always fell parallel to the track and not over the track. And during the study, after that, we established a few formulas to restrict the throw of the blasting, so that within 2 meters or within 5 meters, according to our need. So for that, we developed a burden prediction for a new formula, and it has been published in the Mining Metallurgy and Exploration Journal. Another, we established the throw prediction formula that is unique in nature. And it has been also published in this same journal. And after that, we also established one formula to predict the vibration in nearby condition, like within 2 meter or 5 meter, what should be the vibration. So before the blasting, and at that time, if we know the magnitude of vibration is going to be high, so we have to check so that the failure should not occur over the track. And this is the methodology. You see, we have decided that a charge in each hole differently, so that the moment of the blasting mark can be guided to parallel to the tracks. And here we can see the outcome of the blast, and you see that blasted portion where blasted mark were all were written on the blasted face only. And during the blasting, we achieved the very good slope also. You can see the half cast marking here. And this is the stage 2 rock mass. For this also we devise a new technique so that the blasted material will return after blasting at the places, at their own places. And here you can see the view of before blasting and after blasting. And this is the number of blast on all details. You can see in all the blasting we restricted a throw of material within 2 meters. And in the cases of stage 2 blasting, the number of failure over the tracks were very minimum in comparison to blast. So here, after that, we tried to develop a model using the AI and ML techniques, and it has been published in Engineering Failure Analysis Journal. And with this, we try to predict the failure of track, blasting material towards the track. And we use the 3 machine learning.
One more minute, please conclude.
Oh, okay, sir. I'm going to just coming to the conclusion. This is the view of the stabilized slopes, and the factor of safety for all the slopes were more than 1.2. And this is the cases you can see here. In spite of rainfall in that area is more, the incidence of rockfall and the total number of train interruption were very low after coming years. And here you can see that benefits what railway got is we developed two formula to calculate the time. Actually, at the particular problematic cuttings, railway used to do the speed restriction of train. So with the, our work, they have removed their speed restriction. So they got they saved their time and energy also. So we after this we calculated all these things. You will see the cost of excavation were recouped in within 1 year of time. So this is the conclusion of this all study, and we have published 4 papers out of this study. And if sir, we will give 2 minutes time, I will want to play this video, short video.
The Council of Scientific and Industrial Research, Central Institute of Mining and Fuel Research has achieved a groundbreaking breakthrough with directional control blasting, a cutting-edge technology for slope stabilization, particularly in railway infrastructure.
It was not working.
DCB is designed to fortify railway slopes, facilitate track doubling and upgradation while ensuring uninterrupted railway traffic flow. This innovative technology sets new industry standards, offering precise and efficient blasting operations, making it ideal for sensitive areas where traditional methods are too disruptive. The Konkan Railway successfully implemented CIMFR's DCB technique, revolutionizing railway operations by stabilizing 105 unstable slope cuttings across a vast 52.6 kilometers stretch. Safety was paramount, with no disruptions to scheduled train movements, showcasing a commitment to passenger safety and seamless travel experiences. The results were astounding, eliminating instability in previously problematic areas and enabling smooth train journeys even during challenging monsoon seasons. The Rail Vikas Nigam Limited adopted this technique for doubling tracks in hilly regions for Indian Railways, extending its impact nationwide. Beyond slope stabilization and efficient train traffic, this achievement represents human determination and innovation overcoming challenges. It stands as a beacon of progress, reminding us that dedication and creativity can shape a future where even the most daunting landscapes yield to human ingenuity. USBRL has also adopted DCB technique for excavation of approach roads to proposed Salal railway stations.
That's all.
Okay, thank you. Thank you very much. Now it's open for the questions. Yeah, please.
Yeah. Yeah, static only, sir. Not done. Actually, we did in flag 3D. So in that, actually it was done by Mr. Dr. Arko Jyoti Das. So that time we found just to have some idea of that, what should be the factor of safety after the stabilization. That's why we did. That we did not do. Okay.
Thank you. Any other question? Okay, thank you. Thank you very much, Dr. Narayan, for your wonderful presentation. Thank you. And now we'll move on to the next. I think we have got paper ID 60. Mr. Rishabh Dwivedi. So are you here? Okay, please go ahead. So you've got 8 minutes for your presentation and 2 minutes for your question answer.
So good evening, everyone. Today my topic of presentation is study of progressive thermal damage characteristic of Jalor granites following thermal cyclic effect. So in COP26 held in United Kingdom, our Prime Minister has given Panchamrit mantra for achieving the net zero emission by 2070. In order to achieve that, we have to reduce the use of fossil energy, fossil fuels, and we have to encourage the use of nuclear energy. So right now we are using only, right now nuclear energy is only contributing about 2% of electricity generation in our country. And India has a target of achieving 25% of this electricity generation by nuclear energy till by 2050. So this, with the excess use of nuclear energy, there will be more and more nuclear waste, and it is very important to dispose these waste for safety concerns. So what are nuclear waste repositories? So these are basically facilities designed for the deep geological disposal of radioactive waste. And these waste are basically placed in engineering barrier system, and which is stored in stable rock formations. And these stable rock formations are expected to remain undisturbed for thousands of years. So our objective today is we are basically taking two kind of rocks. One is white granite and another is black granite. So white granite is commonly composed of quartz and alkali feldspar, and black granite has a little bit less content of granite and more content of biotite and amphibole kind of rocks. So here what we are doing actually in nuclear waste repositories, as we can see, there is a waste canister which is surrounded by this engineering barrier system, and which is surrounded by a buffer, and then it is stored in a stable rock formation. So the nuclear waste canister is in direct contact with the engineering barrier system, and which dissipates energy to the stable rock formations. But the rock formation further dissipated throughout its formation at its cool down. So there is a cyclic heating and cooling processes going on. So here what we have done, we have heated our rock samples, Jalor granite rock samples, from 25 degrees Celsius to 250 degrees Celsius, and then we held it for 12 hours, and then we cooled it within the oven, and we repeated this process for 7 times, for 7 cycles. So what we observed, so we have done this Brazil tensile test on these rocks, and we have observed that the white granite, due to its more stable mineralogical composition, is showing this throughout. It is showing this there's a strain softening effect, and the black granite is initially showing strain hardening, then it is showing strain softening. It can be explained because the black granite has more thermal expansion and isotropy than white granite, and it has more mineral heterogeneity. So after this, we have done this. We have assumed that the rock strength follows a Weibull distribution, and we have done this damage versus strain graph, and we observed that the damage is basically what happened due to heating and cooling cycles. The microstructure within the rocks expand and shrinkage. So there is a thermal stress developed within the microstructure, and due to this, thermal cracks develops. So in white granite, because it is more stable, the thermal damages are not much distributed, but in black granite, it is showing a wide distribution. Further, we have taken the damage variables with thermal cycles. So basically what we are observing, the white granite is showing more damage, less distributed damage, and black granite is showing much more distributed damage. So we have also conducted XRD analysis, and we have found that there is not any significant changes, mineralogical changes in in rock samples with the increase in cycle, heating cooling cycle. And we have done this SEM analysis, SEM images, and we can see that in the up to the 7th cycle in black granite, there are several thermal cracks are present, while in white granite there is less thermal cracks. So conclusion is the disparity in thermal expansion between different mineral is more important than individual mineral expansion, and thermal expansion anisotropy is much higher in black granite constituents mineral as compared to white granite. And thermally induced microcracks are found to be prevalent in black granite, and they are found to increase significantly in quantity as the number of thermal cycle increases. And tensile strength shows a declining trend with increasing thermal cycle for white granite, but for black granite, it increases up to third cycle, and it shows this strain hardening, and then it decreases with rise in thermal cycle. Through comparison of the stress and characteristics of hollow granite rock, it has been found that with an increase in thermal cycle, stress strain curve changes from brittle to slightly this strain softening stage. So as a result, we have found that fine-grained white granite with good thermochemical stability should be considered as a suitable candidate as a host rock for India's high-level radioactive waste repository. These are a few references which I followed, and thank you.
Thank you, Mr. Rishabh. Thank you very much. Now it's open for the questions. No questions? Okay. Okay.
Okay, Rishabh, what is the average strength of white granite and black granite?
What, sir?
What is the average strength of both white granite and black granite?
Tensile strength.
Compressive.
Compressive. We have done
Only
Brazilian tensile strength.
What is tensile strength average?
What, sir?
What is average tensile strength of both?
Average tensile strength is approximately 8 MPa for white and approximately 6 MPa for black.
Where this white granite found?
In Jalore area, Rajasthan.
Black granite?
Similar area.
Okay. We have, I myself seen black granite so many places, but white granite I see very less places.
Okay.
So that,
It is basically due to the mineral constituent. The color is basically due to the mineral constituents. White granite is basically dominated by quartz and alkali feldspar, and this black granite has lesser quartz and feldspar, but more and more these amphibole and biotite minerals, which provides its black color.
Okay, thank you.
Thank you.
Okay, thank you. Thank you very much, Mr. Rishabh, for a wonderful presentation. Now we'll move to the next one. Paper ID 7. Mr. Kumar Nilankar. Is he here? No. Next one is paper ID number 6. Mr. Divyanshu Singh. No? Great. The next one is paper ID 144. Mr. Kumar Narendra Kumar. Yeah. Okay, please come. I think it is misspelled here. No? Narendra Mr. Kumar.
Anyone will set up this?
Somebody need to help him.
Or pendrive. Pendrive नहीं है.
पहले से दिया हुआ था पेपर पहले से दिया हुआ
हाँ,
है.
समझ इसमें नहीं है. Next video.
I think this is the last presentation of this technical session. So after this, we'll be closing.
Connect हो जाएगा उसको बुला रहा हूँ. इसमें नहीं है ना, यहाँ पे कहीं पे आपका नहीं है ना प्रेजेंटेशन करने. वो बुलाना पड़ेगा सर.
Paper is not there. Paper is not there within any folder.
Okay. Do you have a pen drive? You can put it on? You don't have a pen drive? No, but there was an issue in getting the input. Yeah. Okay, he is there. Just can you please help?
वीडियो है ना, कोई दिक्कत हाँ पेन ड्राइव ओके यहाँ पे पहले ये फोल्डर रखा हुआ है दीपक कनेक्ट कर सकते इस लैपटॉप को उससे या फिर अच्छा ठीक है पेन ड्राइव में हो गया पेन ड्राइव हाँ पेन ड्राइव में हाँ ये है मुझे ऐसे हाँ इसी में डाली लगा दीजिए लगा के इसको टॉपिक ये काम नहीं करता Okay. I'm not this. This is some confusion. So
yours would be the last one. Your good name?
Slide yeah इसको फुल उसमें करना फुल स्क्रीन
Thank you.
थोड़ा बड़ा जरूर प्लस प्लस पे
अब है कि स्लाइड कहाँ पे डालेंगे टॉपिक क्या होती है
यहाँ से क्यों
तो इसमें है सिस्टम
सिस्टम
आप देखिए आपको ये करना पड़ेगा यहाँ से ड्रैग करना पड़ेगा ठीक है माउस से कर लगा
Mic is working. Good evening, all audience, chair and co-chair. So today I'm going to present a paper on AI solutions for energy geotechniques and disaster management resilience. So basically, I'm doing executive MTech in AIDC, and by profession I'm working as a senior engineering manager for a US-based MNC. So my focus is basically on some software solutions for geo techniques and disaster management, and that is for resilience too. So in abstract, I'm going to explain that why I have taken this particular solution for these situations. So AI has greater capability as of now to help on energy geotechniques and disaster management. So it is emerged as a pivotal area of research, offering innovative solutions to enhance infrastructure resilience and mitigate risk associated with energy-related projects and natural disasters. So through these solutions, we will have very less lead time to take the decision because we have informed data sets. On the basis of those informed data sets, we can take at least near to actual decision that we should have to take in real conditions. And these solutions will work in two-way directions. Two-way directions, I would like to say that we can take data sets, that is historical data sets, since last 100 years we can take, and we can train our solution. And at the same time, we can receive data from receptors, that is different kind of sensors that we can install in different geographical locations. So in two-way directions, we will have a capability to reduce lead time to take the decision in the situation of any kind of disaster or any kind of situation that I'm going to explain you further, that what are the situations that we have taken to develop solutions, AI solutions. So these are the basically two different segments, but I have tried to integrate because energy geotechniques and disaster both are somewhere interconnected or interrelated, because you cannot take energy geotechnique decision without knowing disaster situation. So these are the basically situations: geotechnical risk assessment, real-time monitoring of geotechnical infrastructure and projects. And then we have reservoir management for oil fields and similar kind of products. And then data integration and decision support for geotechnical projects or infrastructure. Then we have automated decision optimization. We will come to know later on about this. Then we have safety improvement and risk mitigation in similar kind of projects, that how we can mitigate risk in real time. In the same way, we have disaster management resilience categories. So we have chosen 4 different categories. So early warning system in case of any disaster, how we can take immediate decision and reach out to the needy people immediately. And then risk assessment, rescue operations, communication, and coordination. So this is a 4-window solution. So in case of any kind of disaster in real time, quickly we can take decision, we can reduce the lead time, and automatically we can ask different kind of groups who are supporting in that region to reach out to the needy people with right set of equipments. So this is the main objective about this particular thing. So quickly, I will go through the solutions. I will not read out each and everything. So role of AI in energy geotechniques. So AI is revolutionizing energy geotechniques by offering advanced solutions to optimize infrastructure design, enhance efficiency, and address geotechnical challenges. In site characterization, AI analyzes geophysical data such as seismic surveys, providing a nuanced understanding of subsurface conditions crucial for energy projects. So as told you in the beginning, that all these solutions will work with two-way data. One is historical data and one is live data that we will get through receptors, through different kind of sensors that we will install as per the need of the particular project. So this is predictive modeling assisting geotechnical risk assessment, predicting potential subsurface inability and optimizing foundation designs. Real-time monitoring empowered by AI ensures the structural integrity and safety of energy infrastructure. AI-driven geomechanically model contribute to the sustainable extraction of resources like geothermal energy or oil and gas. The role of AI in energy geotechnics extends to offshore wind farms, underground energy storage, and other projects where it improves decision-making process. So main thought behind this entire model is to make informed decisions, so that any person who is taking the decision will be fully confident and he can take a right decision at the right time. So that by default will reduce your cost because you have very less lead time and you are taking right decision at right time. So that is a big thing. So the role of AI in As energy demands escalate, AI emerges as an indispensable tool in navigating the complexities of subsurface environments for more sustainable energy future. So first, application. This is application within the AI solution for geotechnical risk assessment. So directly I'm going to the core of this particular solution. So AI facilitates real-time monitoring and predictive modeling. Both the things it will facilitate in case of geotechnical risk assessment. So it continuously processes data from sensors and other monitoring devices, promptly identifying deviations or anomalies that might indicate impending geotechnical risk. So this real-time analysis empowers predictive decision-making, allowing for timely intervention to mitigate potential issues before they escalate. So before something comes, you have at least some concrete data to take the decision, because you cannot take any decision without concrete data. If you take decision without concrete data, there are possibilities that you will take wrong decision or you may be deviated from the right solution. So this is a base of this particular application within a solution. And this is one algorithm on through machine learning. Basically, we can create a model and we can train that model on the basis of last 100 years data. About this, let's say I have a project within Bihar itself. So I can take data of last 100 years about this particular geographic location and I can feed within my application, and it will read it, it will understand it. So now I have, let's say we are people and we learn something through our experiences. So same experience we will provide to the model, it will learn, and then it will have its own decision making understanding. So in real time, let's say we have past data plus we are sensing real time data. So on the basis of past understanding, it can take right decision, and it can inform all the people. Let's say we have a board. In board we have 20 members. So we can inform immediately to all 20 members, this is the situation in this area and this kind of decisions should be taken. These are the resources that we may need in real time.
Kindly wind up. You have 1 minute left.
Sorry?
1 minute left, kindly.
Okay, that is fine. Quickly I'll go. So real-time monitoring, and then we have a reservoir management about the particular geographical area. We can take decision, means AI can take decision that whether it is suitable or not for a reservoir management. Then we have data integration and decision support. So whatever I told you informed decision, it is about that. Then we have automated design optimization. So this is very important thing, but as of now we don't have time to explain in detail. Safety improvement and risk mitigation, this is very important because we have people who are working in the field and you can take right decision at right time to save them. And it will be applicable for any kind of geographic location, including mines, coal fields or oil fields, anything. So, and the second thing, role of AI in disaster management. So as I told you at the beginning, we have 4 window solutions. So early warning system that will take live data and it can predict that what is the intensity of this particular disaster and what could be the problems that happen in this area, what kind of material we may need to support these people within this much of time. It can also tell that what is the casualties and different kind of problems that might happen in that particular area on the basis of the feed. Then we have risk assessment that I told you that on the basis of feed, it will assess the risk of that particular area. And then we have rescue operations. It can automatically launch and call the people who are board of the members within the particular board or people who are helping in that particular area. Automatically it will call, it will message, it will text that this kind of solution you have to provide in that particular area. And then we have rescue operation, and then we have communication and coordination. So as I told you, so it will automatically, so it is a 4 window solution that it will gather data in live situation through the sensors. It will automatically decide that what is the intensity of this particular disaster, and it will automatically call to the people who are rescuer, all the rescuer, that you have to go in this area, and this might be the possibility that different kind of people are trapped or maybe they need this kind of help. So you should have to go along with this resources to those people. So this is briefly about this entire solution, AI solution that I'm proposing.
Thank you, Mr. Narendra. Any question? House open for questions.
Sorry? Volume of data. Volume of data could be anything. We have to decide because, as I told you, we are taking two-way data. One is historical data. So if you are taking historical data, size of data, it could be any, means 1 GB, 2 GB, 10 GB. It depends on size of data is depend on the data itself. What kind of data you are getting. In real time, it can support any size of data. It doesn't have any kind of limitation that it only 1 GB data you can pass or something like that. Because you are taking 100 years, last 100 years data, plus you are taking live sensor-based data from different geographical region. So it depends on capacitor and processors. So we can, it depends on us that what kind of capacitors and processors we are installing. If it has capacity of 1 GB, it will process only 1 GB. If it has capacity of 100 GB, it will process 100 GB. It's all about your installation and investment.
So in fact, I have a question, when we say the data of the past, what is that data which we are picking it up for your study? Can you name few that these are the parameters being picked up as data?
Yes, so we have to set the parameters. For example, this application I have to deploy for earthquake in a particular region. So I will take that kind of data, I'll set the attributes and parameter that what kind of data I need, what is the seismic zone and what is the intensity that may be possible in that area, and in past, what is the different kind of intensive earthquakes came in that area, what was the problems happened during that area. So all similar kind of data sets I will create so in Excel file or somewhere else, and then we can feed within the model to train it.
Have you done any data feeding? Have you done any study, case study?
Case study, I have one case study, so I can show this later on.
Okay.
On earthquake.
That is on earthquake.
Yes.
Which area?
On earthquake, we can train the model, and then on the basis of real-time data, I can predict that what is the problems that may occur in this particular area, in which region.
Which area you picked it up for earthquake?
So I have taken generic data from Government of India.
Okay, thank you. Any questions? Okay, thank you. Huh? Okay, someone?
No, it will not show something in advance. It will be in real time. Let's say right now it is not November. We are in January. So in January, it will not say that what will happen in November. It depends on the real-time data collection through the sensors.
Okay, Mr. Narendra, you can discuss. Yeah.
Okay, thank you very much. I think offline you can,
okay.
Thank you. You can discuss. I think we are having one more paper. Thank you very much for your excellent presentation. Yeah. The next presentation is paper ID 154 by Ms. Mridula, Korea University, Roorkee. So this is the last presentation of this technical session. We were thinking, the previous one to be the last, but this was left out. Previously we called in, but I think she was by mistake there in some other hall.
Shall I start, sir?
Yeah, please.
Please.
Yeah.
Good evening,
You
everyone.
got 8 minutes.
Okay, sir.
Yeah, thank
Good
you.
evening, everyone. I'm Dr. Mridula from Koyer University, Roorkee. So my topic of presentation is utilizing PET for preparation of binder for paver blocks. So you can see two figures placed side by side on the opening slide itself. So this paper is basically the journey of this plastic waste into these paver blocks. So these are some facts and figures about the plastic waste which has been produced by different states of India, and the source for these facts are the Center for Science and Environment 2018 report, which says the Maharashtra is the major producer of the plastic waste in India, and around 20% of the plastic waste which has been generated all around over the world. 56 lakhs tons of plastic is produced in India itself. So if we can see that 19 to 23 million tons of plastic waste, they are dumped, they are leaked into the aquatic systems, they are polluting the lakes, rivers and seas and causing major hazard to our health and to the environment. So the objective of this paper is to develop a technique for preparation of interlocking pavement blocks for utilizing these waste plastic and preparing a principal binding, while we also have to look for the environmental pollution factor, and finally we have evaluated the engineering properties of the finally produced paver blocks. So why we have chosen these PET as binder? So the answer is on everybody's table. If you can see this PET, the commonly used bottles in all around, in all educational institute, in such conferences, these are the major source of plastic pollution in every educational institute. So I come from a university where there are around 5,000 students. So the major source of plastic waste which has been produced in our university is PET. So of all these plastic waste, we have chosen PET for preparing binder. So for preparation of binder, there are 3 stages. The stage 1 is the utilization of plastic waste in the mix as a complete binder with the help of chemicals if required to improve the behavior of the plastic waste as binder, because we were planning to replace the binder that is either bitumen or the cement or the concrete. We are trying to replace it by 100% of the plastic waste binder. So we just needed to improvise its behavior. The stage 2 is the assessment of the environmental impact which has been caused during the melting process of this plastic, and finally attaining the engineering properties of the pavement blocks. So before we started with casting, there are some standard tests which were performed on the binder which has been obtained using PET. So these tests were flash point, fire point, ductility, specific gravity, softening point and the penetration value. So this table compares the standard values of all these standard tests of the bitumen with the molten plastic, and if we can see the ductility and the penetration value test cannot be performed on the molten plastic binder. So to test the samples, we have finally casted 38 samples. The materials which were used are the PET, coarse aggregate, fine aggregate. In 6 samples, we also tried to incorporate lime into that, and finally the bitumen. So the trials were conducted on the following factors. These factors were obtained, these were extracted after the literature survey, which says that if we can vary the temperature at which the plastic binder is being mixed, if we can vary the percentage of the fine aggregate, the percentage of the coarse aggregates. So we have taken these factors, that is what will be the effect of PET content on the paver block, what will be the effect of the percentage of coarse aggregate, what will be the effect of fine aggregate, if required what will be the effect of lime, what will be the effect of curing temperature, and this played a very major role in our study, and what will be the effect of mixing temperature of on paver block performance. So This is the summary of, of 38 casted blocks. 2 were not casted properly because of the inadequate binding material. 13 samples were cured at the room temperature. 19 were cured in the oven by varying temperature between 100 degrees to 150 degree, and this temperature is varied gradually. That is, once the plastic has been converted into binder, it has been allowed to gradually cool down into the oven, and when it is cured at the room temperature, the maximum strength obtained is 13.87 megapascals, and if it is oven cured, the highest strength obtained was the 22 megapascals. So while casting, there are certain problems which were encountered, and the problems are like the layer formation. This is while casting we observe that there is a formation of layers. So there are certain reasons behind this layer formation. There might be the inadequate tamping, the higher percentage of PET content in the mix. Because of the higher percentage, there is a higher rate of cooling at the surface, so it formed a layer before the layer at the inner material is the layer at the outer surface is cooled before at the inner. Entrapped air and filling mold relatively to the higher position. The second problem we encountered is the material settlement from the top part. So this is because of the higher percentage of the PET content, and from this higher content, higher percentage, I mean it is around 60%. If we tried to exceed it beyond 50%, the material started to settle down. Then non-homogeneous casting is basically because of the segregation and the less amount of PET in the mix. Then formation of the air gap in the middle part of the block. Lump formations were observed when we tried to add lime. So finally, we have observed the significant improvement in the compressive strength of the casted samples if the samples were heat cured into the oven. So this picture shows the casted blocks are heat cured into the oven, and we can see that these are there is a significant improvement in the compressive strength of the blocks. This is the comparative study of the plastic waste replacement of the different studies. And if we can compare with these are the different studies. I have not incorporated my study into this because our study has completely replaced this plastic waste by 100%. So we have obtained a strength of 22 megapascals with the heat curing. So these are the finally casted blocks. Interlocking blocks, we are in process of installing these blocks into our campus. We are using this as a parking space, and since they do not require any other binding material, so they are very easy to install. So we have also fortunate enough to have a patent granted in September 2023 over this study also. So this patent was granted on the basis of this design of the mixer, which is trapezoidal in nature, which allows the efficient mixing of the binder. And this was also granted on replacement of the binder by the 100%. So in conclusion, we can say that the strength of the binder is a function of PET before and after exposing to the heat. Better bonding performance can be obtained between the temperature range of 140 to 215 degrees Celsius. If we try to incorporate lime, the strength started decreasing. Decreasing fraction limited to 55% of coarse aggregate gives rise to compressive strength. Heat curing provides sufficient time to mix for the bonding and gaining strength, thereby increasing the strength, and the maximum compressive strength obtained in our study is 22 MPa. Thank you.
Thank you very much, Dr. Mridula. Now it's open for the questions. Yeah. You can just respond.
Yes, sir. Yes, I'm just going back to the previous slide. Okay. It's basically, sir, for around 5 hours, and it varied. It started from 150 degrees to 100 degrees centigrade. We started with the 150 degrees, then gradually decreasing every hour to 140, 130 to 100 degrees. Then after 100 degrees, then the blocks were kept in the room, kept at the room temperature. Sir, all round curing is required. Yes. So because we are gradually reducing the temperature, at that time we are also rotating that sample also.
Is it possible?
So, but heat curing is necessary because without heat curing, it is we cannot even cast that sample because the outer surfaces of that casted samples, they are cooling down immediately, and the inner binder, it remains as it is. So it is required. So we have not worked on the practical approach how this can be performed. We were doing it manually.
Thank you very much. Any other question? No, doesn't look like. Okay, thank you. Thank you very much for the wonderful presentation on waste to wealth. Now I'll request co-chair Professor Rajesh Rai to summarize.
Thank you, sir. So in this session, we have total 8 papers, and that paper is totally different area. So out of 13, we have 8 presenters, and out of 8, 2 are related to blasting from Dr. N.K. Bhagat sir from control blasting, and one is for impact of inaccuracy in design of delay. So 2 papers related to blasting. 2 papers are related to testing. That include the rock testing, laboratory testing. 1 paper is related to planning and determine a calculation of OB handling by software and using Minex. And 1 paper is by Miss Madhurima from subbituminous. 1 paper is on AI, artificial intelligence, and last paper is on utilization of plastic waste and including determine out various geotechnical properties on these bricks.
Okay, thank you. Thank you very much. I think the whole technical session was a wonderful session. We had varied presentations, varied areas by different researchers. And I was really overwhelmed to see the young researchers, the kind of confidence and the way they presented. It was really, really wonderful. I wish. Okay, go ahead. I think Professor Rajesh has got a presentation in some other hall, so he's leaving. So it was really a wonderful session. Wherein the presentation from the young researchers was, I really enjoyed the kind of confidence they had and the way they presented. So they all of the presenters, I think they need a applaud and appreciation to everyone. And now I think next I'll request what to go ahead. Next we have.
Thank you, sir. Thank you.
Okay, thank you.
So, hello. So here we are at the end of this session. And before that, I would like to thank chair and co-chair for their invaluable guidance during this session. And now I will request Mr. A.K. Dawn to please present a memento to our chair. Sir, please.
I'm giving it.
Thank you, sir. So, and finally, I would like to thank all the participants for their active presentation and discussion. So with that word, we mark end for this today's technical session. We will give, sir, at the end of this conference during closing ceremony. Yeah.
On that day?
Yes. Yes.
No,
Yes.
actually, the name will be communicated to that person today only. And he has to be present because Governor of Sikkim is coming for the closing ceremony. So he will give the award at that. He will give the award at that time. So the today only.
Today only it will be today. Yeah. Okay. Thank you.
So late evening, and presentation is going on. 1 or 2 is remaining in LT001 and LT002. So if you want, you can be part of that. And the taxi will be coming in next 10 to 15 minutes. So you can have that taxi and go to the guest house after 10-15 minutes. Meanwhile, you can enjoy the other session. And tomorrow we will start